Hello, everyone. A very good morning, afternoon, or evening to all who are attending this virtual conference. I welcome you all for the very first IoET Conference 2020. We are glad that you could join us at the inception of this beautiful initiative taken by IoET Planet and organized by the entire team of the project team. So, let me introduce you to myself. I am Shreya Shrivaswas. I am the Associate Tech Lead of the project team and hello, everyone. A very good morning, afternoon, or evening to all who are attending this virtual conference. I welcome you all for the very first IoET Conference 2020. We are glad that you could join us at the inception of this beautiful initiative taken by IoET Planet and organized by the entire Hello everyone, a very good morning. Hello everyone, a very good morning, afternoon, or evening to all who are attending this virtual conference. I welcome you all for the very first IoET Conference 2020. We are glad that you could join us at the inception of this beautiful initiative taken by IoET Planet and organized by the entire team of the project team. So let me introduce you to myself. I am Shreya Sriviswas. I am the Associate Tech Lead of the project team and the convener for this conference. Today, I'll be a host throughout this conference. Before we begin, I would like to convey my earnest gratitude towards the speakers and the attendees who have taken their precious time out of their lives and are present here with us in spite of the harsh conditions of the global pandemic. I would also like to convey my heartiest appreciation to all the IoET Planet and the entire team of the project team organizers who have been working tirelessly behind the scenes to make this event a memorable one. Special thanks to Robin Vijay Thomas, who is the sole stream producer and manager for this entire event. So, IoET conference, what is it? What does this conference even stand for? So let me clear that up for you. IoET Conference or Internet of Everything Conference is an open community event of IoET Planet, totally dedicated to IoET research, innovation, application. It covers a wide range of topics from embedded systems to data analytics and ML implementation, having the objective of enabling a vast array of services in areas like e-health, mobility, energy, manufacturing, and agriculture, just to name a few. I would quickly like to address the attendees and inform all of you that you may ask any question or doubt to the speakers through the live chat in the YouTube link. Due to the time constraint, we will be selecting a few of them for the speakers to answer live at the conference. Also, we will be accepting a few attendees to interact with the speakers live. So if interested, please check the description of this live video. Lastly, all attendees are requested to follow the code of conduct while interacting with the community. Moving forward to the conference itself, we have incredible and exciting talks lined up for you all, and we will be beginning with our first talk very shortly. Our first speaker of the day is Mr. Ajit Singh Raina. He is one of the 50 worldwide ARM innovators and the Docker captain in India. He is also the founder of IoET Planet and Collabnix. I welcome you, sir.
Okay. Hello, everyone. Good morning. I'm really excited to be here. Thank you all for joining us at IoET Conference 2020. We are going to have an absolutely a great day today. By the way, there are plenty of exciting talks which is going to happen today. We are going to hear from industry experts, learn from one another, and of course, you are going to see more amazing demos around IoT. We would also like to share few of the new initiatives which we started a week back. So request you all to be here with us, have fun, and make this event successful. In next in next 4 to 5 hours, you will get an opportunity to listen to industry experts as well as IoT enthusiasts, where they will be covering different verticals of IoT. You will get IoT architecture, IoT devices, edge, and cloud architecture. I'm sure you will find it useful and increase your rate of innovation. And that's the reason why we are here to help you in every possible way. Everything we do as an IoT planet is completely community driven. This time, to make IoT conference happen, we have a great partner with us, which I would like to thank both the project team as well as the SRM University for all their support. The project team is extremely active group in SRM University, which aims to extend a platform to expose the students to challenges and the new technology in the field of electronics and to develop their skill set in this area. So thank you, project team, as well as SRM University for a massive help for to make IoET conference happen. Now, if you look at the IoT Planet itself, it is basically a kind of a collaborative platform which is run by our IoT Planet group, which is purely a collaborative platform. IoT Planet is an innovative platform to bring people together for the first time under the one umbrella in order to learn, collaborate, and contribute. It is an open community which is basically dedicated to research, innovation, and application. Today, it is a blogging site and it covers a wide range of topics from embedded system to data analytics and machine learning. And having the objective of enabling a vast arrays of services in the areas like healthcare, mobility, and all. Now, if you look at IoT Planet, this is how the blogging site looks like, since this is the first time which we just started around 1 week back. So definitely you will see a lot of contents coming in, and these contents are coming in from the IoT experts all across the globe. With this, as we believe that individually we specialize together we transform. So now to bring all the global IoT enthusiasts under one umbrella, we are introducing an IoET Slack channel. And we started this Slack channel around few weeks back, and we have already family of around 100 plus members. Now, if you look at the statistic of this Slack channel, we already have around 3,000 plus messages till now and about 15 plus channels, and these are like quite active. So if you really want to collaborate, if you want to go ahead and learn and try to see if you can bring an innovation, I would like you to go ahead and check out this particular Slack channel. You can go to ioetplanet.com to join us. Now, before I end up this slide, I want to talk about top IoT trends, which we are going to cover. Most of them we are going to cover during the today's session. So, if you talk about top 8 IoT trends, we have IoT security, artificial intelligence, edge computing, IoT SaaS offering, right? Software as a service offering, where major of the companies have been, producing those kind of a software, blockchain, industrial IoT, edge computing. So as the whole industry is moving towards the 5G, you are definitely going to see the below trends. And interestingly, in today's talk, you are going to listen about most of them. Most of the speakers are going to talk about it. Last but not the least, I want to thank the committee members which are listed here, and they have done a tremendous work in enabling this, in enabling today event. So they have put all the efforts. It is like their commitment was massive, and we have been planning this from last like 1 month time. So all the thanks to each one of you who has contributed in a massive way. We have been communicating through Slack in multiple ways. So thank you. And with this, I go ahead and let's begin this particular event. And definitely, I'm sure like you are going to like this event, and hope it you will find it more informative. Thank you. So let me go ahead. Okay. Okay, hello everyone. So today, since I am the first speaker, I will go ahead and talk about a Pico project, which I have been working since last several months. It is all about simplifying an object detection and analytics using IoT and Docker. So let's get started. So a little about myself. My name is Ajit Singh Raina. I am a Docker captain as well as an ARM innovator. Right now, I am working as a technical marketing manager in Redis Labs. I have been with Dell EMC for around 8 years. I was part of VMware for 2.5 years, and again in the Logica CMJ itself. I am also a Docker Bangalore meetup organizer, which today has around 10,200 plus members. They are quite active, and we go ahead and try to organize all those events almost every month. I run Collabnik Slack, which has around 4,300 plus members. We have around 100 plus different channels, which talks about Docker, Kubernetes, IoT, as well as DevOps engineering and anything related to the cloud. So IoT Planet is a community which I started around 1 year back with all those partner committees, and today we has around 100 plus members. Early last year, I got a tip of the Captain's Hat Award, which was the nomination coming from around 200 plus community members, as well as 50 plus Docker captains all across the globe. And this was an award which was handed over in front of around 5,000 attendees who were in DockerCon San Francisco. So this was a great opportunity to go ahead, to get a recognition in such a level because of all the hard work which I put in terms of blogging. If you really want to learn about Docker, Kubernetes, and cloud, collabnix.com is a website which you can go ahead and visit. There are around 200 plus blogs which you can find out, which are quite simple to understand. And especially if you really want to start with Docker, there are around 150 plus blogs itself in Docker Swarm. So I would like you to go ahead and check out. It might be informative for you. So I will start with a kind of an attention grabber. So how many of you run Docker on IoT infra? Now there are two important things which I want to consider here. One is containerization and IoT. And you might be thinking about why containerization on IoT, or why running the containers on IoT infrastructure like Raspberry Pi or Jetson Nano. So the whole talk is going to be around these both technologies which will come together and make your work more easy. If you look at the IoT, it is basically changing and transforming everything from your business to life. Now if you look at the left side, right, we have seen, and one of the very popular example is an IoT, Alexa, Amazon Alexa, right? So Amazon Alexa is a way how you do measure of, you talk to Alexa and try to say like turn on the welcome home, turn on the lights, turn on the fan, and those kind of an automation which you might be doing. But in the recent past, what we have seen is you can even say, Alexa, can you set up Kubernetes cluster on AWS cloud? Now, that is the way how we are moving from a human life to a business implementation. And this is really cool in such a way that we are not just limited to home automation, but more on bringing the values in terms of business. Now, why this is important? Why should I really care about IoT? Now, let us go ahead and look at a few of the statistics which will blow your mind. The first one is if you look at 2003, we had around 6.3 billion world population, and the connected devices were just like 500 million. And during the course of time, if you say in 2020, we have around 7.6 billion, but the connected device has raised exponentially in terms of like 50 billion. It is more than the world population itself. And if you look at the connected devices per person, now that is more interesting. 0.08 which you had in 2003, now it has rose to 6.58. It means that at one time with per person we have around 6 different devices, which could be your wristwatch, or which could be something like the medical on the wrist, which you the medical devices which you wear, right? So all of these things. So since the connected devices has increased exponentially, there is something which we need to go ahead and consider when we talk about the IoT devices. If you look at the implementation part, and particularly on the IoT boards today, there are a number of boards which are available. You have a Raspberry Pi, you have a Banana Pi, you have a Jetson Nano board, which comes with an inbuilt embedded GPGPU devices, right? An Arduino board and Orange Pi. There are multiple IoT boards, and these are the IoT boards which can help you in directly or indirectly in some way to go ahead and automate those pieces around. Let's talk about one of the most popular board, which is a Raspberry Pi. It is a low-cost credit card size computer, right? So today, if you really want to have a very low-cost desktop computer, usually people what they have been doing, especially the IoT enthusiasts, they replace your desktop with an IoT device, IoT boards like Raspberry Pi. And since this concept early started in 2006, but officially it got launched in 2012, and today, if you see, every one of us are aware in one way about Raspberry Pi. These are like very small, tiny computers which we use to inspire and educate our children. Now, one of the use case which I recently tried is how about integrating Pi with Celestron telescope. So I had one of the telescope which was hanging around, lying, and I was using is when during the early days, but I really want to make it more smarter, and that is where I went ahead, connected a Raspberry Pi on top of a telescope with a camera module connected, and every 5 minutes I was able to capture the images of moon. So it will be interesting for you to consider that. I don't know whether you are going to believe, but it's the whole implementation was running inside a container. So I have a Docker Swarm cluster running on Raspberry Pi, and then your there is one container which you go ahead and try to convert this particular container into a kind of a CCTV camera, and that was fetching an images. So it was really cool idea to make your lazy telescope as a smart, right, as a smart device. If you look at the Raspberry Pi itself, since the Pico is moreover it relies on Raspberry Pi, so I'm going to talk about Raspberry Pi a lot. It comes in a three models: 1 GB, 2 GB, and 4 GB. So 4 GB was the one which was recently introduced, and then you can go ahead and try out a lot of computation power on top of it. So if you look at the Raspberry Pi, right, it has everything which you need for a laptop. So you have a processor, you have a memory, you have an HDMI port which you can go ahead and connect to it. You have a camera modules, and then the especially the USB drives where you can plug in your mouse and keyboard. Now let's talk about Docker, because since we started with Raspberry Pi and we are talking about the containerization, so let's spend some time in Docker. So today, if anyone asks you about Docker, it refers to several things. One is Docker is a company, it is a product, it is a platform, it's a CLI tool, it is a computer program. Now, the picture which you see is something which I captured way back in 2018 when I visited Docker headquarters. So Docker is a kind of an open platform which helps you to build, ship, and run your application. And it comes with the notion of saying you build somewhere, you build somewhere and run it anywhere, right? And it is going to work. If you look at the architecture of Docker, it is more probably it is an open source tool which is designed to run application using containers. And the way, if you are coming from a virtualization background, so you might be aware that you start with the infrastructure, you have an hypervisor, on top of it you run containers, right? So in terms of Docker itself, you have an infrastructure, you have an host operating system, and then you have a containers which share the resources. And the reason why Docker is so powerful, because it is portable, it is lean, it is very small in size, you can go ahead and deploy it. And the other thing is you can scale it. I can set up a 5 node Docker Swarm cluster in just 5 minutes. So that is the easiness which Docker brings on the table. And today, if you see, it has been like 7 years, and there has been Docker as a platform is again, you can deploy it as a standalone, or you can also deploy it in terms of the orchestration tool which comes by default. Using a Docker Compose, you can go ahead and bring up a containerization or the microservices architecture. So Docker today is a very powerful platform which helps you to go ahead and deploy an application. Sitting on my desktop, I can deploy an application on the cloud, and Docker makes it more easy. Today, Docker runs on all of these platforms. You just call it, and Docker is supported on those platforms. Let's start with the virtual box. Now, if you want to have a multiple operating system on your desktop machine, you can install VirtualBox either on the desktop or on a server, and it works. The other thing is, if you want to run Docker on cloud, yes, we have a support from Windows Server, as well as you can deploy it on Azure, GCP, AWS. All these platforms are supported. And with the latest release, sitting on my desktop, I have an ECS integration, which means that I can just run one single liner command, and it will go ahead and deploy a containerized environment on AWS. And we do have a support for Azure, which has come recently. Other than that, the interesting fact is you can even run Docker containers on IoT devices. And yes, you read it right, it is supported. Today, if you really want to install Docker on IoT devices, which could be a Raspberry Pi, Orange Pi, Banana Pi, Jetson, it is just like a one-liner command. And you will be surprised to know that in a Jetson Nano, NVIDIA Jetson Nano, it comes by default. So any software coming by default in any of the device is a matter of the business decision which is made by the company. Docker coming as a default is definitely, there is a huge opportunity which is tied around it. When you talk about Docker support on Raspberry Pi 4, so all you have to do is just run a simple curl command, and that's it. It will go ahead, fetch the packages, it will install, and now your system is all up and ready, going ahead. You can run the Docker, you can create a Docker images, you can run Docker containers. And this support has come in a standard Raspbian OS. So right now they have changed the name to Raspberry Pi OS, but usually the support cycle is only for the Raspbian OS. But it should work. Like if you go ahead and deploy in any of those boards, the same command, because this is a Linux based command, and it should work. Now, this is a kind of a glimpse of how the 4 node Kubernetes cluster running on Raspberry Pi. Now, you might be surprised, like, what is Kubernetes doing here? Kubernetes is, if you look at the Kubernetes, it's a kind of a complex architecture, and it's basically a combination of large number of open source tools. But we do have a very lightweight Kubernetes called as K3s, which has been built by the Rancher team, and this is a very lightweight Kubernetes which you can go ahead and run on top of this. And if you look at this particular setup, you have a camera modules. There are 3 camera modules which is connected on those 3 Raspberry Pis, and I have been using this stack for a long time to blog around it, to go ahead and try out the monitoring tools and all sort of things which you do with the IoT automation. So till now, you might be thinking about why the hell IoT needs Docker. So let's go and touch upon a few of the important points, which I think it's very important for us to know. The first thing is, if you have ever worked on OpenCV and ever tried to compile it on top of Raspberry Pi, you know the pain, right? You have to have a lot of binaries and libraries which you need to tie up to go ahead and install OpenCV. But think of the way where if I go ahead and containerize the OpenCV, and if you run it in a single command, I think that's a magic it brings, right? So you can build, ship, and run IoT software with just a matter of one single liner command. The other thing is, it is a minimal hardware resource. So in order to try a deep learning platform, why do I need to go to the cloud? I can even do it on my Raspberry Pi itself, right? Even the Jetson Nano boards, those boards comes with a GPGPU device. I can leverage them, right? So we require a very minimal resource, and they consume very limited space. I don't need a data center, right? Which is like 24 past 7 running air condition, and then cooling my systems. I just need a minimal hardware resource to make it work. Now, geographical distribution in such a way that you can have a multiple a Raspberry Pi in a different location, and you should be able to go ahead and push your software to those devices seamlessly. And if you have looked, there are around 100,000 of Raspberry Pis, and how you go ahead and push the software is very seamless. Just one liner command, and it will go ahead and scale your application. The fourth one is a limited and sporadic network access. Now think of it as like this Raspberry Pi, they come with a very limited network bandwidth. And if you really want to have an application, say, think of it as like you have a drone where you have connected a Raspberry Pi on top of it, and I want to go ahead and stream something. So with the limited and sporadic network access, you can go ahead and run those containers, which consumes very less resources, network resource. And then the widely varying device environments. The thing is, I can have a mix and make model of all those Arduino IoT boards, right? And then they are going to work together. So if I have a mix of Jetson Nano as well as Raspberry Pi, if I want to deploy an application, it will deploy seamlessly, because I am going to use an ARM based Docker images, which will go ahead and get deployed on those IoT boards. So these are the primary 5 reasons why we would need IoT need Docker. Now let's look at one of the demo which I have, turning your Raspberry Pi into CCTV camera. Now, if I ask you to go ahead and try it out, one of the things which you will realize that the first thing is you need to get a software. You need to install Python, and then you write a code, and after that you just run on top of it. But how come? How about if you want to deploy it on containers? So the whole idea of how we set up this demonstration is, if you have ever looked at Raspberry Pi, you have a camera module port, and this is the camera module which you see in the center. You just have to go ahead and try to connect your camera module onto this particular module camera port, and that's it. Now, if you want to really want to try it out, so all you can do is you can go ahead and clone this repo. Just try to build it. Just say raspi-config, which is for the configuration of camera interface, and then it should, and that's it. You just go ahead and just configure those camera interface, and it should work. So let's look this into the action. So I have a kind of a Raspberry Pi cluster, and right now the camera module is connected to one of the Raspberry Pi. At this point of time, this is my Docker version, which is running on my Raspberry Pi. So I can do a sudo docker ps. So there are few of the containers which are running, so we really don't have to worry about it. So once you clone this repo, all you have to go to is docker cctv raspbian and just execute this particular run.sh. So run.sh is a script where I am trying to run a docker run command, mounting the devices, and then exposing it in port 8081. So let's go ahead and try to run this particular script. You can see that it has created a Docker container with a container ID, which is 258. Let's wait for some time. Because during the course of time, and one of the things which you really need to understand is there is a kind of a modprof command which you need to go ahead and run on top of Raspberry Pi, so that the Broadcom processor recognizes these particular interfaces, and this enable it for Docker. So when you say Docker PS, you will see that there is a Docker container which is running, and this is getting exposed to port 8081. I can do a Docker logs command to see how it works. So at this point of time, it has you could see there is a camera one which is enabled, and it is trying to pre-capture the buffer, and you could see, and this is how it looks like. So my setup at this point of time looks like something like this, where I have 3 node cluster. One is Jetson, the other one are Raspberry Pi. So at this point of time I have connected to just one, so you can see just one of the nodes. So we saw that how you can turn your Raspberry Pi into a CCTV camera. Now let's talk about Pico and try to find out our problem statement. What we are here to talk about. Now you might be knowing about in an apartment or in a flat, right? You have a kind of a DVR security system. Now these are the digital video recorders, which is essentially a computer, and it saves security video images to a hard drive. This we all are aware of. Now, the drawback or the limitation of this DVR security system is the data lasts only for 2 to 3 weeks time. The real-time DVR system is high because you have to go ahead and install on top of it, lack of video and text analytics. So if I ask you, like, you might have certain cameras which is installed in your apartment, and if I want to really go ahead and check a kind of how many unregistered cars have entered into the building, you might not be aware of that. You might not have a statistic or metrics around it, right? So those kind of analytics, I'm talking about video and text analytics, is not possible today. But if you really want to go ahead and purchase that, it is very costly, and which is not affordable by any general public, right? So I come up with something very interesting called as the Pico project, and let's talk about it. So Pico project is all about an object detection and analytics. It uses Docker, Raspberry Pi, Docker Swarm, AWS Lambda recognition system, and Apache Kafka. So on the left-hand side, what you see is more of a producer code which runs on Raspberry Pi. On the right-hand side, what you see which runs on the cloud, and how they are, the message is flowing in between them is we will see during the course of time. Now this is whole architecture how Pico works. So you have a Raspberry on the left hand side. If you see, you have a Raspberry Pi capturing a video frames via camera modules, and these packages, and again it is capturing the packets in the form of a container. See, there is a container which runs and which converts your Raspberry Pi into CCTV camera. After that, those packages are sent to Apache Kafka. Now, this is something which is happening over the public IP address where it goes ahead and Kafka is running as a 3 node cluster on cloud. Okay. And once it hits the topic, which is a very integral part of Kafka, it triggers AWS Lambda functions. And this is a simple Python script which I have used. Once it triggers, it tries to fetches the frames. Once it detects the object in the frame, that goes to the Amazon recognition service. Okay, and both of the trigger part as well as the detection is happening by one consumer script, which I'm going to show you in a demo. And after that, this stores the video frame images in S3 buckets, and after that, whatever you see is in terms of a web UI. So the whole implementation is done by just 3 containers running some kind of a Python scripts. One is a producer, one is the Kafka, and the other one is the consumer code. Now, this is how we implement a deep learning platform in 3 easy steps. On producer, you say Docker run Pico producer. On a consumer, you have to type Docker run Pico consumer, and that's it. You just have to bring an object in front of your camera, and that's the magic happens, right? And in between, there is an Apache Kafka, which is sitting there and it is pre-configured and it runs on Docker Swarm. And usually when we deploy microservices across the cluster, we use Docker stack deploy. Now, Apache Kafka could be something which is new to you and why we are trying to, why we try to adopt it. So let's look at the Apache Kafka. It is a community distributed event streaming. So it is very powerful in event streaming. And there are a lot of capabilities which we try to go ahead and try to evaluate. One is it is a distributed, which means that it basically works on a pub sub model, right? How the publisher publishes an images and then the consumer consumes it. So it stores, it receives, it sends messages on a different nodes. It is horizontally scalable, which means that I can add more and more nodes, which Zookeeper as one of the component of Kafka, which can go ahead and detect it. It is a fault tolerant. We don't have a single point of failure. Even if your one of the nodes goes down, your manager nodes or the Swarm manager is going to handle it. It is persistent to disk. You can have the records of those images which you can store it on the disk, high throughput, and commit logs. Now, if you look at the architecture of Kafka, it is simple. It is not complex at all. So if you see here on the top, we have 3 producers, and down we have a consumers, and in between you have a Kafka cluster. So right now I have a 3 node cluster. One is the leader and two are the followers. And once the images, right, the producer writes the images onto the Kafka cluster, and once the image is ready to the topic, it triggers an AWS Lambda, and that is where the Zookeeper comes, which manages those clusters and it monitors it. And after that, you have a consumer. Consumer in our case is an AWS Lambda and Amazon recognition service. Producer in our case is a Raspberry Pi. Now, this is how the 3 node cluster look like. We have a Kafka manager as well as the Kafka slave nodes, which goes ahead and run on top of it. So this is just to give you an idea about how you can, how when you run it, you can visualize it with the Swarm visualizer. One of the things which we didn't talk about is Amazon recognition service. Now we can implement Pico on-prem, and that is one of the effort which is going on right now. But if you really want to use or leverage the cloud services, Amazon recognition is one of the leading deep learning platform which basically can help you in object detection. It can object and it does the object and skin detection, facial analysis, face recognition, and facial recognition. All those things, it's kind of, it's a, if you go to the Amazon cloud, you can see a lot of features which it talks about. But in our case, we just use that as a consumer code. Now let's go ahead and try to demonstrate. I will demonstrate a text analytics and then few of the images which talks about the video analytics. So let me show you a simple example here. So this example is I have placed a kind of a board in front of my camera, and where it is written as a Docker captain. And since this demo is all about a text analytics, all I have to do is I will run a kind of a the first I will run a consumer code, And this is the code which I'm running on the cloud. This is my Raspberry Pi interface, and I can show you how to go ahead and configure it from the start. So this is Raspberry Pi system which runs Debian Stretch, Debian 9. Let me talk about let me see if what version of Docker version I have. So by default in Jetson Nano as well as Raspberry Pi, you can go ahead and install 1809, right? So the first thing which you need to do is you need to configure your camera module. So let me go ahead and say raspi-config. I need to run it as root. So let me run this command. You will see an option called as interface, and under that interfacing option, under that you have to go ahead and enable the camera, and this is done. Once you enable this camera, the second step would be how you go ahead and enable these modules. So we have a BCM modules which we need to go ahead and enable it. And all you have to do on the producer side, you have a producer code which you can go ahead and run. So now I have a container which is running. Okay, so I have a Pico producer which is up and running. So as soon as I run a producer, you will soon see that it will try to, your camera module will try to evaluate all those text. So at this point of time, it hasn't captured, but soon you will see that. Okay, so let's wait for 2 minutes. Yeah, you can see here, it is a Docker Captain, which it shows as a confidence was around 99, 97%, 94%. So this is how the text analytics works. Now let's look at the object detection. So this is one of the example which I can show you. So I have a kind of a mobile device which I placed in front of the camera, and it has a traffic, the list of the number of cars, and you can look this particular solution. Like it just took me around 2 to 3 minutes to implement it. But if you look at how it is detecting, it is trying to detect your mobile devices as well as the cars as well as the person, right? You can see there, and this is the probability, like what is the confidence level, which could be around, it is showing around 98%. And you can see here the vehicles, it is trying to detect each of the objects which comes in front, even the mobile device and the cars. Let us look at the other example which shows like one of the person and what are the activities he is doing. It is if you look at this particular example, you can see the person as well as it is detecting the computer keyboard. Now there might be a lot of solution available in the market which you can try it out, but this is something which is running inside a container, and it just takes you just like 2 to 3 commands which you have to go ahead and run it and implement it. Now I'm at the end of my presentation. So for the reference, we have a kind of, you can go ahead and if you are really interested, you can go ahead and refer to Pico project, which is hosted under collabnix/Pico. So it is completely open source. There are a few of the blogs which I have written, turn your Raspberry Pi into CCTV camera, and how you can run Kafka on AWS platform. And especially you will see major of these blogs coming in IoET Planet, because that is a platform where we are planning to go ahead and put it. So thank you so much for listening, and do reach out to me if you have any questions. I will be there available and have fun. Yeah. So while we tested it is not like a kind of a production environment, but usually this is something which we tested it with the normal cameras, right? I'm not sure about the actual one, because this is something which we did quite some time back. But you can go ahead and make certain changes in FPS itself, unless and until you have, because these are the images which you are pushing into the cloud. So it all matters about how is the network connectivity altogether. What I would suggest is, like, when if you really want to have concerned about the FPS, you can go to the configuration file and make the changes. It all depends upon what kind of implementation which you need. Since we did it with a different FPS, It means that you can go ahead and customize it. There shouldn't be a problem. The only thing which you need to consider is there has to be a very good network when you are sending these packages to the cloud. Okay, so right now that is the limitation because you need to go ahead and you need to go ahead and pass the privilege flag. But one of the things which you really need to see is there are certain parameters or environmental variables which you can pass. I don't know whether you heard about caps underscore all. So those kind of the privilege flags which you can go ahead and pass on as an environmental variable. I would suggest you to look if you can visit to docs.docker.com. There is a kind of an alternative parameter which you need to pass on to the Docker run command to make it happen. So you can use that instead of passing the privilege flag. Yeah, thank you everyone. It was great talking and have fun.
Thank you, sir, for that energizing start to the conference. Up next, we have a talk on scaling IoT from
Yeah,
prototype to
thank
production.
you.
The speakers will be up here shortly. Please wait for a couple of minutes. Great pleasure to welcome Mr. David Tischler and Mr. Anuj Deshpande at this conference. Mr. Tischler is an ARM innovator, much like Mr. Ajit Singh Raina, and a developer advocate at Belina. Mr. Deshpande is a hardware engineer at Belina as well. Over to you both. Great pleasure to welcome Mr. David Tischler and Mr. Anuj Deshpande at this conference. Mr. Tischler is an ARM innovator, much like Mr. Ajit Singh Raina, and a developer advocate at Belina. Mr. Deshpande is a hardware engineer at Belina as well. Over to you both.
All right. Let me over to here. Yeah, perfect. It looks like we're backwards. I see that Anuj is me and I am Anuj. But hi everyone, I'm David. I am a developer advocate at Balena. I'm joined by Anuj, who I think may have said hello while I was rebooting my laptop trying to get audio working, but turns out my audio might have actually been fine. I think I think OBS may have been playing a trick on us. Anuj, you want to say hello, or did you already?
So hi guys, I'm Anuj. I work at Balena as a hardware engineer, and today I'll be presenting with David about scaling IoT from prototype to production.
Yeah, I'm looking forward to it. It's going to be a lot of fun. And actually, Ajit did us a huge favor and covered a lot of the core technology that we're going to be covering. So he's already kind of set us up for success. So Anuj, if you want to put your screen share up with the slides, I'll go ahead and get us started. Or is it already up and I'm just not seeing it?
It's
there
now. Yeah.
All right, perfect. So what we're going to be covering, like Anuj just mentioned, is scaling IoT from prototype to production. And what that essentially means is that, you know, as Ajit was showing you in his Pico cluster there on his desk, you know, it's great that we've got these low-cost options like Raspberry Pis or Jetson Nanos or other types of, you know, readily available hardware to prototype and build on. And that's all well and good when it's on your desk, but it gets a little bit tricky once you start going into production, building a product that is intended to be deployed into the real world, and it's no longer on your desk. So we are going to be covering that transition from prototype to product and what scaling looks like. So we're going to cover devices, containers, and as I just mentioned, scaling, and show off a couple things you can try at home as well. Anuj, you want to flip the slide? And yeah, I saw our names flash by there. We'll get, you know, we'll make sure that all our contact information gets dropped into the YouTube chat, into the comments, or gets distributed at the end. I don't know. I'll check with the organizers to see. I don't know if the slide decks are going to get shared out after the fact or not, but we'll definitely make sure and make sure we're available. So with that, let's do some cooking. Anuj, what's up next here? Etcher? Does anyone know who Balena is? Is anyone out there familiar with Balena or Balena Cloud? If you've ever flashed an SD card on a Raspberry Pi or for a Raspberry Pi, you actually have perhaps used Etcher. That is our SD card or USB image writing software. There are some others out there, but you know, we certainly prefer Etcher. So let's see. Anuj, you mind going one more? All right. So Etcher, as I mentioned, is a pretty popular utility out there in the open source world for flashing SD cards. But you know, our core product is actually Balena Cloud. And Balena Cloud is what we're going to be talking about today, which is a platform for deploying and managing fleets of connected devices at scale. So as I was just saying, once you get up to 20 or 50 or 100 or 1,000 devices, you need a way to actually reliably manage and maintain those. It's great when they're on your desk, but once they go out into the world, things get a little bit trickier. So Balena Cloud helps with that process. We also have Balena OS and Balena Engine as part of the stack. Balena OS is a Yocto-based Linux distribution. It's slimmed down. We build a custom version for the various devices that we support, like the Raspberry Pis, the Jetson Nanos. The newest one I think we just released is actually the Coral board, the Google Coral Mini, I think is what it's called. And then Balena Engine, as Ajit was talking about Docker earlier and the container runtime, Balena Engine is a fork or a spin of the open source version of that, the Moby project. And it is, again, slimmed down, and it is essentially custom tailored for IoT deployment. So it's it's got some fault tolerance built in, and handles Delta downloads for smaller download sizes and a few other features. And we'll get into that in a little bit as well. Anuj, you want to flip that? So we started to cover this a little bit, but IoT fleet management. If you want to keep going, Anuj, we will take a quick look. So, we saw a Raspberry Pi, a single Raspberry Pi on your desk. Yes, it's easy to hack on. It's cheap. They're readily available. But when you get up to, okay, in this case, how many are on there? 9? Well, if they can fit on your desk, yeah, you can still manage them. But what happens as they continue to grow and multiply? And in that scenario, they're not even all the same type of devices. So it gets a little bit unwieldy here. And once they, like I said, are out in the wild and you no longer have physical control of them, and they're perhaps spread all across the globe, you need a way to continue to manage and maintain those devices. Now, we do have actually devices all around the world. There's one little problem there that I identified on that map with an X, though, which is China. And due to the firewall, we're not able to deploy devices into China. So if that's on your product roadmap, unfortunately, you'll have to come up with a different solution there. But that should give you a quick overview of what Balena Cloud and fleet management is all about. And then Anuj, if you want to take it away, I'm more interested in seeing what it takes to actually build something.
All right, thanks, David, for that introduction. So what we're going to do is we're going to start from the cloud and then make our way through to the device and then build an application. The application that we are building today is called a Balena Dash. So Balena Dash is basically a screen that you can put things on. So let's say you have a Raspberry Pi, you connect a touch screen or a normal screen to it over HDMI. What you want to do is you want to display web pages, you want to display a photo album, or you want to display anything that you want. So that's what we are going to do with the application bit today. So the first thing that we're going to do is we're going to go to Balena. Okay, let me just sign out and sign in again. So this is the URL. So dashboard.balenacloud.com. And you can log in with your Google or GitHub ID. I'm going to log in with my Google here. And this is what you see when you log into the Balena dashboard. Now, what you would do is once you open Balena dashboard, you basically create a new application. Let's call it IoET, right? And you're going to select the device type. Now, here you can have a Raspberry Pi. Here you can have a Beagle board, a bunch of Beagle boards. Here you can have an Intel Edison or an Intel NUC. So there's a bunch of devices that we support. Today we are going to use a Balena Fin, which is a device that's compatible with Raspberry Pi. It has a Raspberry Pi compute module. And let's just create this application. So this application will have a default device type, which will be the Balena Fin. But if the architecture is compatible, you can add other device types here as well. So now once you've created a device type, what you do is you say add a device, and that will open up this window where you can essentially fill out the details. So there are two types of operating systems that we have, one that we use for development and one that we use for production. And here I'm just going to put in my Wi-Fi credentials. So now what this is going to do is when you go to raspberrypi.org or any site, you can download a .iso image that you flash onto the SD card, right? This is going to create a image file, and it's going to configure it to connect to the application that we just created. Other than that, it's also going to add Wi-Fi credentials, so I don't have to connect a screen, connect a keyboard, and then put in my Wi-Fi and do those kind of things that you typically have to do with the Raspberry Pi. So this is going to configure my Wi-Fi credentials by default. When I say download Balena OS, it will begin download. It's going to take a bit, so let's take a look at some other things in the while. What I'm going to do is actually, it's going to take actually more than what I expected. So what I've done is I've already downloaded a file here for this particular application, which is a similar application. And I'm going to just select that particular thing. So flash from file, and yeah, this. I'm going to select this, and I'm going to say open. So this application that I have open right now, this is Balena Etcher. This is the one that David was talking about a couple of minutes before. Now, what we have to do is we have to connect the Balena fin over USB to my laptop so that it has access to the onboard eMMC, which is a replacement for the SD card, right? And what it does is I have an 8 GB version. So when I go here, you'll see that it's initializing a compute module. This compute module is basically the one on my fin. Is my video visible at all? Yeah. Okay. Where should I go? Yeah. So if you look at my video, you will see that I have this device. This is the Balena fin, and this is connected over USB to my laptop. And now, as you can see on my screen, this has been detected as a compute module. So I'm just going to say continue, and I'm going to say flash. Now what this is doing is this is basically taking the application that I downloaded from this particular application. There's also another one that I'm downloading for IoET, but let's just look at this one because that's taking a bit of time. So this particular application, and what I see is there's some other devices here, but we added a new device and we are downloading that. I'm just going to get rid of this device so that things are a bit cleaner. Right. Meanwhile, HR has been busy flashing the device for us. So what it's doing is the device that has been connected over USB to my laptop. Like I said, it has an eMMC thing, which is like a storage module. And instead of SD card, we'll be using that on the Balena fin. eMMC is typically. Yeah. Go ahead, David.
Sorry to interrupt you, Anush. So real quickly, you said that the Balena fin is compatible with a Raspberry Pi 3 because it's using the compute module. So I have a Raspberry Pi 3 on my desk right here. Could I actually deploy the same application then that you've got?
Yes, you can, absolutely. So that's the good thing about, the Balena fin, that whatever you do on a Raspberry Pi, everything that you do on a Raspberry Pi, all of that works. And yes, so now this was not visible, but what I've done is I had that device connected using a USB port to my computer. And now what I've done is I have just connected that to a power supply here. And I also have an HDMI going to the small display screen. And there is also USB going to the display screen, which is powering it up. So I'm just going to go back to my dashboard, and on my dashboard,
Yeah, tilt up. There you go.
yeah. Right. And now, as you can see on my screen, there is a new device that was just added on this application. We deleted one device that was already there, and now you can see that there's a new device called Hidden Sound that's already here. And now what it's doing is it's downloading the image that was there for Balena Dash. Now, what I did there was basically I just went to this particular application and I said, download the code. So I download the zip file here, right? And you can see that it downloaded Balena Dash master. Let me open my command prompt. I'm going to open this as administrator. To do this, I have installed the Balena command on my, hope this is visible enough. Yeah. So I have installed the Balena command, and I have done something known as Balena login, so that my dashboard is synchronized with the command line tool that I have here. Once I have done that, let's just create a folder called IoET. I'm going to go to IoET, and I am going to copy okay. Font. I think this is the maximum size for the size.
It might be the screen resolution.
Yeah, okay.
Um,
Let's see if this is better. Is this better?
Yep.
Okay. So I've just logged into my WSL Linux part of Windows. And what I'm going to do is I'm just going to create a folder called IoET. I'm going to go to that folder, and I'm just going to download this here. Once I've downloaded that zip file, as you can see, this is balena-dash.get. I'm going to unzip this. Wait, why does it show us? Okay. Copy link. Yeah. I'm just going to download this zip file and unzip it so that I have the source code for this particular repo. Now, once I have done this, what I'm going to do is I'm just going to say Balena push. What you have to look for is in this particular folder, there is a Docker compose file. Now let's take a look at this Docker compose file. A Docker compose file basically tells Balena Cloud and the device that these are the different services that are going to be there on the device, right? So for this particular application that we have, Balena Dash, I want these different services. So what I'm going to do is I'm going to say Balena push and the name of the app. The name of the app is this. So this is applications Balena Dash. So I'm just going to write Balena Dash here. Now, when I do that, what the Balena command line tool does is takes these files that I have in my on my laptop and sends them over to Balena Cloud. Balena Cloud is responsible for creating an image based on these files and then sending that image to the device. Once you start doing this, what Balena does is it looks at the image smartly and decides that there are deltas in it. So you don't have to upload the entire image. You just have to upload the changes to it. so on and so forth. But what it's doing right now is it's starting a build for Balena Dash. Balena Dash is the application, and this is my username, Anuj Deshpande, right? And this is the dashboard link. So this dashboard link is this, right? And it's basically building on a server on Balena's cloud. What we can also do is do this locally. So once we have a device, we can do something known as enable local mode. So once we do enable local mode, we can do all of these things that we are doing on Balena's cloud locally so that our development time is faster, right? But once you have things deployed in the field, that's not really an option for us. That's when we start doing like doing the builds on the cloud itself instead of doing it locally. So now what's happening is these are all the logs that are coming from Balena's cloud over here, and it's telling me if I have some warnings or errors in the source code that I have. There are a few warnings, but I don't think we have to worry about them a lot. So once we do that, what will happen is that a new release will be created for this particular application, and all the devices that are in this particular application will be updated to that, unless you have a different policy based on releases that you don't want to change. So this is the current release. So as you can see, it's C4EC7E7. This will, the things that are happening on my CLI right now, the things that you can see on the CLI, this will create a new release. And basically you will see here, this is building a new release called BDA42C4. So this is an existing release, C4EC. Now, because I've made some changes to it, it's pushing a new release that will then get downloaded on my device here. In the meanwhile, what I'm also going to do is, yeah, so this unicorn is a sign that everything went smoothly and the source code that I pushed did not have any errors. And this shows you the different services that are there in the source code that I pushed. So what we are basically doing is we are using a version of Docker. So Balena has made changes to that for IoT and made it slimmer and so on and so forth. But basically, we have containerized our application into 4 different services. The name of the services are Kiosk, Scheduler, Wi-Fi Connect, and Photos. And now these services are being updated on my device. So you can see the progress bar here. So basically, I'm making some changes that are now being synced with all the devices that I have in Balena Cloud, right? And you can see here the current release is C4EC and the target release is BD424C4 or something like that, right? These are the UUIDs for the release. Other than that, I have IP address here. This is the IP address on my local network for the device. And all right, so this has started some application, and now we can see the logs for the device. So this is another important feature of the Balena Cloud and Balena OS and the Balena engine, is that you can see the logs for a device remotely. So if this device was with David in Arizona right now, I would still see the logs. It's not related to this device, being here with me. The next thing that we are going to do is we are going to take a look at some of these things. So there are some configuration variables here. So one of the configuration variables that we're interested in is the device GPU in memory, device GPU memory in megabytes. So on a Raspberry Pi, you can configure how much of the memory is allocated to the GPU. 16 feels a little low because what I'm doing is I'm driving a small HDMI screen and I'm going to show photos on that and so on and so forth. So what I'm going to do is I'm going to set it to 128. I could probably do it a little more, but let's start with 128. So now what it's going to do is this particular variable has been changed. So if you look at the device, it's going to kill the service and start it again. So this is better than, shutting off the device and rebooting it again. But it kind of has the same effect. And what it's going to do is it's going to update the configuration variable on the device itself, so that based on that configuration variable, if there are some changes that are to be happened in my source, those will happen in my software, those will happen. In the meanwhile, let's take a look at this particular page. So if you notice, 192.168.86.20 is the local URL for my device. I'm just going to open that here, and I'm going to add a port number because I know what's happening in the URL in the application here. So 8080 is one of the ports on which one of these services run. So right now they're still exited. So that means that they haven't started up properly, but they will start up in just a minute. Okay, if you can see the device now, there are some things that are happening on the screen, but basically what's happening is the changes that we have done are taking effect. All right, let's give it a second to settle down.
Anush, while that's going on, I
Yeah.
do see the Bellina logo over there, but did you add me to that?
Yes, yeah. So one of the features that we also have in Balena is collaboration, right? So when I create an application, right, I need to, I can, like, I usually always work with someone on an application, right? And very rare cases are you working completely alone. So you can add people anywhere in the world. So I believe I can add David. David, is this right?
It's a little small. I can't quite see. Should be there's a underscore David underscore, and then there's a
Tischler
one.
one.
Yeah, one on the end.
Yeah. Okay, so now I'm going to invite David to my particular application, right? And that's going to allow him to be a developer here so that he can add his own devices to this particular application. Not just that, he will also get access to my devices, and he'll be able to make changes to that. So there are different types of team members that you can add. If you just want to give read access, you can kind of do that. Or if you want to give complete access, you can add him as a developer, so on and so forth. So this is going to allow him to create a copy of what we are doing here in Arizona, and we'll soon see that. But in the meanwhile, you can see that now I have this screen that's connected to this particular device, and I have the Balena logo on it visible. Now let's take a look at this particular thing again. So this is the URL that we were looking at earlier. And here on port 8080 of this URL, there is a small dialog box. So let's add something here. So let's add Balena IO's URL here. Let's see what happens. So when I say show URL, it says currently showing balena.io. And if you look at this display, the display is being refreshed right now as we speak with that particular URL. So what we did was we configured that URL to show balena.io, and that's what the display is showing now. Right? Let's do something else. Let's take this particular URL, right? This is the conference URL. Let's take the home page, right? And let's configure that on my display. So I'm going to say show URL here again. And as you can see, the display went blank for a second, and then we have the IoET conference webpage open on it again. And then, this is a typical touch screen. So I can do this, right? I can scroll it so that we can read about the event or something like that, right? So this is also showing the logs of all the things that are happening as I was doing that on the device in devices configuration page. So you can see conf IoT, planet, home, HTML, Balena data. These are the things that we basically added, right? All right, next, let's take a look at our slides. So we created an account for the dashboard. We created an application. The application was readily available to us. It's one of the many example applications that Balena has. All of these are, again, like 100% open source. You can find the license for it. You can contribute to it. You can fork it, make changes to it, distribute it, whatever you want, right? So we created an account on dashboard.balena-cloud.com, and then we created an application. Then we added a device using our trusty old Balena etcher, which is this. So any device which boots over an SD card or a USB device, or if it has its onboard storage like the Balena Fin. So we added that device, and then we pushed our code. Pushed our code is this part where we see the unicorn, right? We said Balena push to Balena dash.
The unicorn does have a name, by the way. His name is Charlie.
Okay. Yeah. So that's kind of like the mascot that we have on a CLI. So yeah, so the hardware that we used for this was Balena Fin, which is an industrial Raspberry Pi. So it has quite a lot of interesting features when you compare it to the Raspberry Pi. The one that I like the most is that it has an onboard 8 GB storage module, so you don't have to rely on SD cards. And if you do IoT for long enough, you'll realize that SD cards are one of the weakest link in the chain. Then we used Balena OS. So to do the Balena OS was downloaded by, you go to this application, you say add a device, and then you say download Balena OS, right? So the Balena OS is similar to Raspbian or something like that. It's based on Yocto. It's a very, I would say it's optimized highly for IoT. So everything that you can do on a typical Raspberry Pi, you'll still be able to do that, but it's like a slimmed down version, optimized for updates in the field and so on and so forth. There are two versions. There's a development version of Balena OS that we are using right now, and there is a production OS. So there are some changes when it comes to the security policy. So one is optimized for development and one is optimized for production. So that's the Balena OS. Balena engine is the part that orchestrates all of the things related to the containers, right? Like it will make sure that everything is running smoothly, that RAM is allocated properly, the delta downloads when I make an update to it. So all of these things, this is something done by the Balena engine. It's based on Mobi project from the Docker Foundation. And yeah, so I'll share the link to the slide so that you have all of these things that we did. And basically what we did was we had Balena dash deploy.
And in the meantime, if you want to go back to your dashboard, you should see a second device has come online. So I have my camera on this Pi 3 here on my desk. After you added me to the application, I did the exact same steps that you did, which was download the SD card image, flash it with Etcher, and power up my Pi. I think I am most likely still in the updating. Yeah, I'm now pulling down those containers that you had previously deployed. So it looks like my device is about 60% of the way done. So it's getting there. But
let's take a quick look at how we can also see these devices. So this is a fleet map, like the location map, and you can see here that I'm in Pune near Mumbai in India, and there's a device here for Balena dash application. If you go to the US, you can see Arizona, and that's David's house. And basically that's where the second device that he just added, this particular Raspberry Pi, is online. Let's take a look at what his device is up to. So his device is downloading the BDA 4.2.C4 release that we pushed from here. So this is the BDA 4.2.C4 release. And what his device is doing is right now it is in the factory build mode. That means it didn't have anything on it. And now it's downloading the latest release so that even he will have a similar display connected to a Raspberry Pi, and he'll be able to show things on his own. So what this allows you is to, so what we did was we first went to members and we just added David Tischler 1, which is David's username. And then after that, he was able to add devices without doing a lot of software development or anything like that. I had already pushed the application. The application was there with Balena Cloud. When his device connected, all his device had to do was just sync up with Balena Cloud and download that application. And that it has done. It's still downloading that, but yeah, there are some things that will have to change. So if we go to device configuration, you will see that his device is still on 16 GB memory, 16 MB memory for the GPU. We can change that. So the good way to change that using Balena Cloud is to go to fleet configuration and say that any new device that connects will be set to 128 megabytes for the GPU. And I'm just going to say that this is 128. So that means that we don't have to manage devices on a per device basis. We can just go to the application and select fleet configuration, and basically that will take care of setting that up for all the new devices that are added after this point. All right, let's go back to our slides.
Yeah, I want to check real quick on time also. I know that we got a late start, but
I think we are like 20 minutes overboard
yeah.
based on our schedule. But I think, yeah.
Yeah, I guess it sort of depends on if we've got the time or not. Do you think it's okay to address a few of them?
Sure.
Okay.
Well,
yeah, let me scroll up.
oh, that's an interesting one. And
Yeah, that is a very good one. I mean, I definitely would say that it is one of our core
cornerstones.
pieces.
Yeah, it's one of the cornerstones of
Yeah.
Balena as a brand, I believe.
Yep.
There's a lot of other technical things that do happen at Balena, but in terms of, I think Balena's, like, why people know Balena, I think HR is like one of the key reasons there.
Yep. No, I agree. I mean, millions of uses per month. So yeah, it's a key piece. Okay.
I have some opinions, but David, I'd like to hear yours first.
Well, I would actually alter that question, and this is certainly opinionated, being internal, but I would say it's not that we are keeping up. I would say that actually we are pushing the boundaries, and we are the ones doing the innovation, and that the other providers are following our lead. The key statement right there in that one is the VPN tunneling. We were the only one that did it in that manner. And it's only recently that AWS has implemented that. I would say Delta downloads are still one of the features that I believe, certainly correct me if I'm wrong, but I believe we're one of the only ones doing that. So I would say actually we do a lot of the real bleeding edge innovation where the big companies just don't have, they're just not as nimble, and they end up following our footsteps.
That's kind of true, because if you look at the feature specs of Balena Cloud with Azure or AWS, there's still a wide, I would think. The other thing is that Balena doesn't care about the data that you're collecting, or all of those things. All of the providers that you mentioned, AWS, GCP, Azure, they have like data services. They have S3 and they have whatever Azure and Google Cloud. Balena is closer to GitHub than to these guys, I would say, because we just care about how you deploy your code and how you manage your code. We are not interested in, where you store your data, how you collect your data, and all of those things. We are not interested in that at all, right? So that's a key differentiation. Just like you wouldn't store your data on GitHub, there's no easy way, there's no way to store like your users' data or things like that on Balena Cloud, right? We care about code more than data, which kind of like makes us different than the other services that you mentioned.
Yeah, I mean, the core competency for Balena
Yeah,
Cloud
exactly.
is fleet management. Simple as that.
Yeah.
Yep. Yep. Yeah, so we kind of went fast. I know we covered a lot of ground in this session. You can mix and match device types so long as the architecture is the same. So using an example of like a BeagleBone and a Raspberry Pi, those are both 32-bit ARM devices. Or a Raspberry Pi could actually go either way, but you can deploy a 32-bit ARM OS to those. Or you can mix and match 64-bit ARM devices such as a Jetson Nano and a Raspberry Pi 4. A Fin uses a 32-bit OS by default, so a Fin plus a Raspberry Pi 3 or 2 plus a BeagleBone would be fine. But you cannot cross over the architecture boundary, so you can't mix and match an x86 device like an Intel NUC with a Pi. You'd have to have separate applications for that. And Anuj, correct me if I'm missing anything there.
So that's the thing. So with devices, the good thing about what we do is we have creative control over things like Balena OS. So I believe we are the first ones to do a 64-bit OS for the Raspberry Pi, and by that extension for the Balena Fin as well. So we have a 64-bit OS that works on Raspberry Pi 4. Plus, it also works on Raspberry Pi 3, so we can even have that running on Balena Fin. But yeah, with Raspberry Pi 4, I think you have to pick 64-bit OS.
Yeah.
But yeah, like those are the kind of considerations that you have to have when you are doing like different devices on the same application. But yeah, it's totally doable.
Yep.
Sure. Thank you.
All right. Yep.
All right.
Thank you, Mr. Tishler and Mr. Deshpande, for such an incredible talk. I am sure the audience is inspired through your demonstrations.
Thank you.
Moving
All
ahead,
right.
the
Thanks,
next talk will intrigue all the AI in hardware or AI in general enthusiasts. The topic for the next talk is
Well,
HANA,
yeah, no worries. I had it
abbreviated
easy.
for
Anuj did
Hardware-Aware
all the
Neural Network
talking.
Architectures
David's used
using
to that kind of
SPNet.
thing.
Give us a
Yeah.
few minutes to queue
Got a
up
lot
the
of
next
practice.
speaker.
Yeah.
All right. I'll see you guys.
All right. Bye, guys. Thanks.
Mr. Sai Vineet is an AI hardware engineer and also a Carnegie Mellon University graduate. It's my pleasure to have you at this platform, Mr. Vineet. Without any further delay, over to you.
Hola. I wish I could listen to the intro, but
Mr. Sai Vineet is an AI hardware engineer and also a Carnegie Mellon
sure, sure.
University graduate. It's my pleasure to have you at this platform, Mr. Vineet.
Just say
Without
go,
any
okay?
further delay, over to you.
Yep. So hi everyone. So my name is Vineet, and I'm calling in from Silicon Valley in California. And so I'm so happy to be invited here today by the IoET team. So I want to just take a quick 10 seconds and convey my kudos to the IoET team here for organizing such a wonderful conference. And it's always fun to have like-minded people in one place and discussing about stuff that they like. That's the cool part of a conference, right? So a little bit about myself before we start discussing on what we want to do today. So basically, I have done my bachelor's from SRM with ECE degree, and then I went on to do my master's at Carnegie Mellon. And I also did a master's degree in electrical and computer engineering, more oriented towards AI hardware. So what is AI hardware? AI hardware is basically a new field of sciences slash businesses that are opening up to solve slash compute AI workloads at a pace faster than GPUs, right? So I spend a lot of my time designing AI hardware systems, and I'm currently working for a stealth mode startup in Bay Area that is also building full stack AI hardware systems, right? So an example of full stack AI hardware system would be like the CPU rack, right, at Google, which has a set of AI hardware chips all stacked together, and they all compute a pretty big neural network model or something like that, right? So that has been my area of interest. The time when I spent at CMU specializing on AI hardware, I had a very cool coursework called Hardware Architectures of Machine Learning. And in this coursework, I had spent some time doing research on the topic that you're seeing right in front of you, right? So the topic is hardware-aware neural architecture search, right? So we will deep dive into this research topic. This will be more of into inspiring you into trying out a new research topic in the area of AI and IoT. So without any further ado, let's just deep dive into this, right? So basically, as we all know, AI is basically it involves a science of studying about this artificial intelligence and how you can decipher patterns from data and learn from it and infer it later. So machine learning and deep learning are a set of algorithms that leverage this science and create algorithms that can be trained over a set of data, capture this pattern as mathematical models, and later use them to infer another data point which you want to classify or regress into a particular value of, right? So this area has always been fascinating, and it's and I just wanted to realize how I can run So just now that this is set up as our baseline, let's go to the next slide, right? So if you see here in this particular slide, right, so this particular slide shows us that the evolution of computer vision algorithms, let's say object detection algorithm, especially for a data set like ImageNet. And you can clearly see that the models itself, each of the bubble here represents a model. And you can clearly see that the models itself are getting bigger and bigger in size, literally. So you can clearly see that the operations are increasing and the number of parameters that is required to train the model is also increasing pretty significantly. So it is going from 5 million to 155 million. And today we are talking about models with up to 1 trillion parameters or so, right? So what is a parameter basically? A parameter is basically a set of weights that we use in a neural network to capture some information about the data that is being sent into it when being trained over a loss algorithm. Right. So I am assuming a little bit of AI basic knowledge here, but if that is not there, too feel free to ask in the question answer discussion, and I can explain more. So so one thing we have to know here is all these models that the people from the research side are producing for computer detection, object detection and computer vision and stuff. They're all trained in very comfortable scenarios. Like they use NVIDIA GPUs, Titan RTX, and all these cool GPUs. They use like data center racks, hundreds of chips stacked together, and they train models with huge parameters that will take hours to train, right? So recently, there has been some effort into trying to reduce these AI models small enough, or at least compress them so that you could probably run them in a CPU, probably like an Intel i9 core, which MacBook has. If you have ever trained models in MacBook, then that's what MacBook has, I guess. And we also have, so basically, yeah, so there has been some effort into from the research community as to shrink these models and be able to run them in CPUs, right? But CPUs are also not so great at what they are doing, but the research community does not seem to understand this, and they still create models that are big in size and have a lot of parameters, right? So there has been some effort into trying to reduce these models into different trying to reduce these models parameters that needs to be learned and the computations that it takes to run one iteration of the model itself. So every time when I mention a model, I'm mentioning a neural network architecture that over which data is given as an input to, right? So the one that you see on the top left is called a mobile net convolution. It's basically trying to reduce the number of parameters required to do a basic convolution or an ordinary convolution and still maintain the same expressibility of the parameters or the weights in the network itself, or basically capture the same close to same information by reducing the amount of computation you require to do that, right? And in the bottom right is another model that has been recently discovered. So the top left is mobile net and the bottom right is condensed net. So both mobile net and condensed net that you see here are basically designed for embedded systems. So they are not designed for GPUs or TPUs. They were designed to fit and run on embedded systems. But again, when I mean embedded systems, what they are doing is this on an iPhone. And you guys know that on an iPhone or a Samsung or an high-end smartphone has enough compute capability equal to your laptops these days, right? So what me and my team at CMU have realized is no one is really worrying about this here. What you see here to the left is Raspberry Pi, right? So no one is really worried about how can we run giant models on an IoT chip like Raspberry Pi, because Raspberry Pi's computation capability is significantly smaller compared to GPU and TPUs. So how can we go about and run it, right? So the motivation behind why you want to run such huge models on IoT is here. So I guess it's probably here. Yeah, right. So every time when we think about having AI on an IoT chip, I mean IoT application, it is not always the same application, right? So you can see a nice simple graph that I've done here. So you can see there is an x-axis is latency and y-axis is energy, right? So let us say you want to deploy an object detection module to your drone, right? So what happens in the case of a drone is around 96% or so energy goes into keeping the propeller on and therefore keeping the drone high. So you hardly have 4% of energy left on the chip for you to do any kind of computation, let alone AI workloads, right? But at the same time, in the case of a drone, you are fine with it taking more time for it to do the surveillance itself. So let us say if a drone is trying to surveillance a place, you can have a lower frame rate and still get ahead, be fine with it. Whereas if you see the other end of the spectrum in the top left, you can see a self-driving car. It's Google Waymo's, and you see a lot of these Waymo's going around here. And I was told that one of the speakers in our conference, David, is from Phoenix, Arizona. And I'm pretty sure there's a lot of self-driving cars of Google Waymo going around there as well. I would like to know more about how's it going out there. So this Waymo car is a self-driving car, right? And the thing with self-driving car is it has a lot of on-demand juice as an energy for you. So it has like car batteries, well-recharged car batteries. You can always use as much as you want to perform any big AI model or computation or workload you want. But the fun part is you cannot I should say, the difference here between the drone and the self-driving scenario is in the drone scenario, you're fine with having higher latency to achieve one inference. Let us say if you want to classify it as like a dog or a cat or a human being, you're fine with it taking 3 or 4 seconds. Whereas if you take the self-driving scenario, you have to detect a stop sign instantly, right? Because every second that you take a delay to detect the stop sign, you are basically crashing the car into another car basically. So you can see here, even though in both scenarios I'm trying to do object detection, you can see that the environments that these models are deployed in are way different. So in the drone scenario, you have the environment where you have very less energy, but you're okay with having high latency. And in the self-driving scenario, you have a scenario where you have all the energy, but you have to shrink your latency as much as possible, right? So what I see the trend here is there are a variety of applications within the spectrum of self-driving cars to drones, which have different energy and latency requirements to achieve their functionality, right? So today's IoT, right, industry, IoT or IIoT, AI is basically focused here. So they are more like, I cannot shove a lot of energy into the IoT chip because IoT chip is not capable of it. Instead, I'll just take a hit and I will have a hit on my latency. And that's why you don't see people using Raspberry Pis or something like that on a self-driving car, because it takes a long time to make the inference and therefore the car will go ahead, right? So we were actually thinking in our research team, can we push this position of IoT today to here, right? The goal is, instead of actually compromising on latency, can I reduce both energy and latency on the chip that you are trying to run this model on, right? So this is the problem statement / inspiration towards what I'm going to talk next. So if you guys have been following me till now, then I'm happy. Okay, awesome. So yeah, this is kind of what we want to do here. We are done with all the research people having all the GPUs and TPUs and all the cool chips. We as hobbyist programmers want to run AI models on Raspberry Pi and other IoT devices because half the time that's what we have, right? So, and you can see here the arrow mark represents the computing capability available all the way from Raspberry Pi to a data center stack, right? So let's go ahead and see. So that's where we are segueing into. So basically, I want to talk about this project of mine, HANA. So HANA actually stands for Hardware-Aware Neural Network Architectures, right? So generally, neural network architectures are not aware of the hardware that they go into, but we were thinking, can we build a neural network architecture that is also training itself based on the hardware it is going into? And we will see how we achieved that as a research project of ours at CMU, right? So you can see here, 3 things are very important, not the tortoise. I don't know if the tortoise or a turtle bad with animals, but so this is fast, right? You want the latency to be as less as possible. You want the model accuracy to be as sharp, as accurate as possible, let's say. And you want the energy efficiency to be higher or the energy consumed to be lower, right? So how do you let the neural network not just know about the accuracy, but also know about the latency and latency and the energy when it's training is all what I'm going to discuss rest of the time here, right? So let's get into a very interesting topic that has been it's been there for 2 years or so in the field of neural network architecture. So this topic is neural architecture search, right? So the idea is, what we generally do when we are trying to find out the best neural architecture for a given workload and a given device is we take a search space of all the architectures possible that can solve the problem. It's a pretty huge search space, to be honest. And then we manually tweak these models, exactly like what the spanner sign shows here, right? You have to change hyperparameters, let's say learning rate, or you want to say like the initialization parameter, the learning rate scheduling, and all this kind of stuff. You manually change it, right? And every time you manually sample an architecture, you then train it, then evaluate it, and then do the performance. And that is how that has been happening till date. Basically, there's a human in the loop, and it is a process that gets delayed, right? Instead, there has been a new concept called as neural architecture search. So the idea is you have a parent architecture that searches for its own child architectures, right? So you still feed the same search space into the parent architecture, but this time the sampling of what architecture you want to pick from the search space of architectures happens by a neural network that trains itself on how to pick the next architecture that I think would be closer to the goal I want to achieve, right? So here you can see all of this is automated, right? In fact, the term AutoML, which you guys might have heard, in fact, is basically a variant, or should I say, the next level version of a kind of a neural architecture search algorithm, right? And you can see here, this is more automatic, right? So the key thing that we have to understand from this slide is, till now, I mean, before neural architecture search algorithm was invented, people were trying to manually design the architectures and try whether they can be, whether they suit the performance. Whereas now we have a neural architecture that can search for neural architectures within itself that can meet the performance, accuracy, and latency, right? So why am I telling you all this? This is why, right? So if I can switch the neural architecture search algorithm to not just be focusing on accuracy, but we focus on the hardware also, right? So if you see the difference between the previous diagram and this diagram, you can quickly notice there's a smartphone in between them, or usually the target device, right? An edge device, basically. So what you do is you take the search space of architecture, and you have a defined search space. You cannot have an infinite search space. You take the defined search space and you run this search space into the target device once and collect all the benchmarks. What is the energy that is consumed? What is the latency that is consumed, etc. And then you let it go through a stochastic supernet. Stochastic supernet is basically the parent network architecture that I was talking about, which actually trains and figures out what are the child neural architectures it requires, right? And when this process keeps on happening, you can train whatever the child architecture that was sampled for that particular iteration of the training, and quickly see as to how well it's running on your target device. So the key difference that we have to note from the previous one and this one is this neural architecture search is aware of the hardware it is going into, right? So, okay, that's cool, but how do you embed the aspect? How do you embed the aspect of how much energy and latency it consumes onto the hardware itself, right? So there has been some effort that was going on in this direction. So these are called as FB networks or FB nets. So FB nets has come from Facebook AI research, which is currently being led by Yoshua Bengio, I guess, who is also the Turing Award winner for 2019 and also one of the key personnel to make deep learning what it is today, right? So Facebook AI research has come up with a very cool way of searching for child networks given a parent network, right? So you can see the architecture here, right? So you have fixed first block and you have a fixed last block in what you want to search. And everything in between is named as TBS or to be searched, right? And we can say, okay, there are so many ways you can tune the parameters to search it. How are we gonna define the infinite search space? Simple. So what they proposed is they have a set of parameters like kernel parameters, expansion parameters, etc., which would be boring if we get into. But basically the idea is you take a set of possible possible finite block types that you can take, that you can replace in this to be search space, so that the parent architecture will know what block to pick to better suit the loss algorithm that we have, right? And I'll come back to the loss algorithm in some time, right? So if you see here, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, I guess. So there are 9 different type of blocks that can go into each of the block that you want to fit in, so that based on the loss algorithm you have, the parent architecture will try to fit whatever block it deems suits whatever suits the loss algorithm or reduces the loss, basically, right? So this approach of training a parent architecture to pick child architectures that suits the loss algorithm is basically defined as DNAS approach, right? So the DNAS approach stands for differential neural architecture search approach, right? So yeah, so so one thing we have to know here is, I will quickly go through the loss function here, basically. So the loss function here states that if I have an architecture and if I have weights of the architecture, then what FBNet's proposed is, we can have one term that takes care of how accurate the model is, and we can have another term that takes care of how much time it takes for that model to run on the chip, right? So, but if you think about it, every time if I want to take a sample and run it on the chip, that is the entire problem, right? Because chip is too slow. You don't want to run it on the chip while you are training it to make it better for the chip. That's a counterintuitive approach, right? So what FBNet does is pretty simple. So what they do is, they know that this is going to be the search space, right? So they know there are going to be 9 blocks, and there are going to be just what 20, 22 layers here. And you can figure out the number of layers by seeing the n value here and adding them up. So around 22 layers they search for, and each layer, there are going to be 9 blocks. So the total possibility of networks is 22 cross 9. But how they are connected is way more than that. So I hope you guys can get a difference, understand the difference there. So what we do is we put in each block in each of the search space, and then try to figure out as to what is the latency that is taken. Can you give me 1 second? Sorry. Okay. Yep. Can you guys hear me? Hope I can. Hope you guys can. Sorry about that. Yeah. I had my friend knocking at my door. So okay. So yeah. So now we know that there are going to be 22 cross 9 possibilities only, right? So quickly, why don't you run those layers, each of them, on the hardware of your interest? It could be Raspberry Pi, it could be Arduino, etc., and then create a text file of all the values with respect to what the latency numbers and energy numbers would look like when these layers are actually run on the chip, right? So later, what they do is, each time the parent architecture samples a child architecture, it takes the accuracy based on the dataset itself, and it takes the latency by simply just adding up all the blocks that are being picked for that particular iteration. Let us say block 2 was picked here, block 3, 5, 6, 7, 8, 9. Then it will go refer the text file, see what the latency would be consumed if it was run on the chip, because we already collected that data, and then you take a sum of all of that. Then it basically means the sum of the entire latency of the model itself. So this way you don't run the model on chip, but you still have a pretty close accuracy, pretty closely accurate latency number on how much time it would take for it to run on the chip, right? So this is a very interesting, but it was a breakthrough in differentiable neural architecture search for hardware. So sounds interesting. Could people not think of text files? Yeah, they could not. So right. So each block that I mentioned here basically looks like this. Again, we can go into the depth of this. The goal is more about telling about how it ends up, how all of this connects, right? So 1 second, my slides. Okay, fine. We can go into a lot of math here, but I just want to go into some of the understanding of how this works. So first thing that you do is you pick a candidate block that you see in the previous slide here, based on the probability for a given layer. Then you sample an architecture from this search space of probabilities. Then you fetch the output for those given inputs and find the accuracy. Then you fetch the latency, find that, and then you differentiate all the weights in your neural network and optimize those weights by taking the differentiation of the loss with respect to all the weights in the network. All right, so that's like very simple trick there. The one thing new that's done by FBnets is instead of just taking accuracy alone, they also take latency into consideration, right? So yeah, now let's talk about HANA, right? So what our research team did was when we saw FBnets paper, we were like, yes, this is exactly what we want to do. But one thing that FBnets misses out is it does not talk about energy. You don't see energy term here, right? So what we did was, okay, why don't we add an energy term too in the loss function? So as you can see here, now we have a loss function that has cross entropy loss, that is the accuracy, takes care of accuracy, you have latency, and you have energy, right? So the key thing that we should notice here is just adding energy alone is not enough, right? It is about how much you want to tweak towards energy and how much you want to tweak towards latency when you're trying to search for the architecture itself. So the parameters here, alpha, beta, gamma, and delta, help you to do that. For example, let us take a scenario of the drone, right? So you want to penalize the neural network when it is trying to fetch a network of higher energy. So what you do is you increase the gamma, right? Because you don't have so much energy on the drone, and you are fine with the network taking a lot of latency. That's okay. So you decrease the alpha. You decrease the alpha. You increase the gamma. Then the loss function will penalize the network in such a way that it will try to reduce the energy and increase the latency, right? Similarly, in the self-driving case, what you can do is you can switch alpha gamma values here. So you can have your alpha very high so that the loss will penalize the network to don't have your loss high, keep it low, and alpha keeping high will do that. And similarly, you will have the gamma low so that the network is fine increasing the energy and it will still not penalize it, basically. So without going a lot of technical details here, I just want to tell you that this is a very flexible way of controlling how much importance / dominance should the network have on about the latency, and how much importance you want to give about the energy that the network takes on the chip, right? So this is a very cool graph that we captured after performing the HANA project, right? So the thing about HANA here is you can clearly see, same like in this slide here where we had energy and latency. I hope you guys remember that, it's too far away, but let me quickly go there. Yeah, so you guys see, you guys hopefully remember this slide, right? So we have energy and latency. We were able to reproduce the same thing with this neural architecture search, right? Hardware aware neural architecture search. So you can see here that we are able to sample a variety of models all the way from lowest latency to the highest latency, all the way from the lowest energy to the highest energy, all by just tweaking alpha, beta, gamma, and delta. So the data set was Cypher10 data set, and the model we used was the FBNet model, right? So the only difference in that model is we added energy to the loss function, right? And you can clearly see, so what is one thing that is beautiful about the neural architecture search algorithm is you can see the models, all of them come into a distribution called as a Pareto distribution. It's called a Pareto curve. The beauty about Pareto curve is it tells you how flexible your loss algorithm is, so that you can create a model, any model of your interest, based on just defining alpha, beta, gamma, delta. For example, if I want it to be a drone scenario, what I would do is I will take something that is lower in the y-axis, say this one, and I'll take something that's higher in the latency or something like that. I'll probably pick this one, and what I would do later is for the self-driving scenario, I'll pick something that is higher in the energy and lower in the latency, probably somewhere here, right? Or maybe even here for that matter, right? So now you have this newfound flexibility as to, instead of training an algorithm and then realizing, oh, this does not work on a Raspberry Pi, you can pre-check how these layers work on Raspberry Pi, feed these text files into the model, and then you can see what is the latency energy consumed, and then you can create architectures like this, which is the beauty. So one key thing we should note here is the bubble itself. The size of the bubble represents the accuracy of the model, right? So you can clearly see that you cannot always get everything. So if you want lowest energy and lowest latency, your accuracy is going to drop significantly because your model shrinks, right? So there is not enough parameters or neurons basically to learn what the data is trying to say here, right? So there, the key about engineering in general is how do you model the trade-off into the algorithm that you have. So this is all about modeling the trade-off. And later, based on the hardware you want, you can tweak alpha, beta, gamma, delta, and end up somewhere in this graph. And you will always have a point or a model that can be better fit into the hardware of your interest. So the way we were able to prove that this algorithm works was by taking other neural networks that are there in the literature, like mobile net and condensed net. The names is not important. Let's just say they are top performers, right? And you can see mobile net and condensed net consume across like 18 joules, 9 joules, etc. on Raspberry Pi. They took 7 seconds and 4 seconds, to run on Raspberry Pi. Whereas we were able to train, or let us say we trained like 30 different sample points, and we picked one architecture that was working the best for us. We had some dip on accuracy, say 4% less, but for on the same data set, we were able to do significantly less latency, 2.88, and energy also is less. So what we have ended up, basically, we have come back to, as I was saying in the previous graph. Oh, right now? Oh, already? Okay. Can you give me 5 minutes? I'll wrap it up and I'll be open to take as many questions as you want. Right? Yeah, but thanks for letting me know. So yeah, basically the key that I want to mention here is, I wish I did not add this transition or so, but we have ended up here basically. We have finally come to a place where we can tweak alpha, beta, gamma, delta so that your energy is also less and latency is also less. And I was able to run a 29-layer deep learning model with significantly better accuracy. I mean, with not a lot of hit to the accuracy, but with good energy consumption and with less energy consumption and less latency, which is exactly what you want to achieve, right? So you don't want the hardware to suffer because of this. So quick thing on how I did this was I just used a Raspberry Pi. I used a power jive. The power jive is a very cute, handy instrument that lets you collect dynamic current and dynamic voltage on the chip when a particular workload is taking place. So at least I hope people know that Raspberry Pi does not, as far as I know, does not have an inbuilt way to profile the energy and latency out of the chip. So I had to use this. But if you use other devices like Jetson, I think you already have enough command line commands to fetch the values. So these are some of nice graphs that I have here that shows as to how the accuracy, alpha, beta, gamma, delta, energy, all these come into picture and helps you sample architectures of different space. So feel free to go through these algorithms. I'll be sharing the slides later. There's a lot of graphs. Obviously, as a project, you try to fill it with a lot of graphs, but these are very useful graphs. Helps to let you know that the algorithm is really working, right? So this is one of the cool websites that I had built for this project. So my end goal was this, right? So all of this algorithm does not make sense to an end user as long as you can capsule this and provide it to the user itself. So I quickly spun up a server system and I wrote my own, JavaScript/CSS/React file to quickly give the picture of what I'm trying to do here, right? So you have 4 parameters here: alpha, beta, gamma, and delta. And based on whether it's a drone, car, or whatever that is, you can increase or decrease the alpha, beta values here, and so the gamma, delta values also, and just provide the latency file, the energy file, the name of your model, and the target device you are basically sending that to. And the next thing you do is basically you submit your model for training, right? So that's it. That's all you need to do. And this is how the future is going to be, is what I believe in. And already Google Cloud, GCP is already doing this, if you guys are familiar with. So the GCP asks you whether you're sending to a TPU or a Coral Mini or Edge TPU, whatever that is. And it helps you to train or compress the architecture according to the hardware it goes into. So this is more like a deep dive or like a little bit of a sneak peek into what is happening inside, right? So never before has it been tried to try along with energy with latency. This is the first project that I know of that tries energy with latency while training the algorithm. So that's kind of what I have today. I just wanted to quickly show you my GitHub repo and also send you the link to that. You have all the code base here. It is not maintained, but feel free to fiddle around with it. I have an archive paper explaining everything in detail if you're really interested. It has the results, the graphs, and obviously the website. It has a JavaScript website, so feel free to play around with the website if you're a web fan. And this is the tensor board. Oh, yeah, sure. Okay, so my username is pretty long. So I will actually send this to my send this to the YouTube chat or somewhere, or I can just send it to the Google Meet, whatever right now. But I can send you, not to worry. I'll send you all my details. So the fun part here is the code is available for you to try it out. Probably you can reproduce results. I'll be happy because the code repository is not maintained. One key thing you can notice here is you can totally see that over iterations, the algorithm is able to pick models with higher accuracy while reducing their energy and latency based on the alpha beta values provided. So this thing works, and we were so happy it works. And I just wanted to share this with you guys and hope it inspires you to how to do AI on IoT and train AI so that it fits onto the IoT or not the other way around. You don't want the IoT to fit to the AI, you know. So yeah, that's what I have. Yep, sure. Okay. How did we come up with the equation to reduce the energy loss? So yeah, a little bit technical topic there. So basically what we do in neural network architecture search or any neural network architecture in general is you create a loss graph, or it's called a loss profile, as to if I change my hyperparameters or my parameters, let's say the weights in such a manner, what are the possible values that the loss can take, right? So the key is you have to keep this loss curve convex. Convex meaning that you should have one or maybe few optimal solutions to that problem. If you have many optimal, let's say this is how your loss surface is, then you have at least 100 different solutions to the problem and you're not actually solving the problem and your loss surface is bad, right? So the key is to do a little bit of linear algebra, little bit of differentiation, little bit of understanding into how the exponential parameters and multiplication parameters work and how they create the loss surface. In fact, one quick thing I can show you is apart from different from other model architectures that uses softmax, this model architecture uses Gumbel softmax. So the key with Gumbel softmax is whenever you're trying to pick a block of a probability and stuff, it can still be a discrete, or let us say there is like called a flat step in the loss profile and it is not smooth, right? So what this Gumbel softmax does is whenever it sees a flat step in the loss profile, it just smoothens it out. So we also use this in our algorithm to create a smooth loss curve, and the equation was also designed keeping that in the mind. It's a lot. So if you're interested in knowing more about this, I would suggest you to pick up this topic called as convex optimization. It's a very cool mathematical hot topic in AI, and it will help you to know more as to how to create these equations for loss equations, basically. Yeah. Okay, you're talking like Amitabh Bachchan from KBC, dude. So what difference does hardware awareness of a neural network create as compared to a network which isn't aware of its hardware? Good question. So the network is not at fault here, really, right? So the key here is when you let the network train by having the awareness of the hardware, what it does is when it searches for the network itself, it tries to pick layers of lesser computation that is taking less compute flops, because the amount of flops you have in a GPU is like in teraflops range, right? Or at least gigaflops range. Whereas I'm pretty sure on a Raspberry Pi you won't have gigaflops or so. I don't know the right number, but that is not the flop amount you have, right? So either you can go ahead and wait for Raspberry Pi to take years to complete that computation, or you can reduce all the unnecessary computations, calculations, and fit the computation needs of that particular architecture itself onto the chip. For a human, this is a very hard process to do because we don't intuitively understand energy, latency, and training algorithms. But it seems like an AI is better to define itself. So here the ML is doing a good job of defining its own algorithm. So basically the answer here is when a network is aware of the hardware it is going into, it is also aware of how much computation it can run and what is the energy it will consume. And therefore it will fit the needs of the hardware than just bombarding the hardware with super high workloads. Have you ever tried running like 2 3 servers on Raspberry Pi heats up, right? So it has like a clock gating circuit that just starts up and you have like a red symbol saying its temperature is high and everything. Do you really want that to happen when you're running a 29 layer deep learning model? You don't want that to happen. You want to save the hardware. Yet you don't have another hardware. So what do? You train the network to itself figure out how to better fit for the hardware. So this is what the awareness is all about. Yeah.
Okay, thank you, Vineet, for that. That's all the time we have for right now, and we'll wind up.
Okay. Sure. Thank you so much, guys.
Thank you.
It was nice talking to you.
Thank you, Mr. Vineet, for that extremely informative and wonderful talk of yours. Up next, we have a talk on Make Your Own Gadget, Embedded Devices for Pen Testing. Please wait for a few minutes while we queue up the next speaker in the conference video stream. Thank you, Mr. Vineet. welcome Mr. Tarun Singh, who is a high performance computing engineer and also a security enthusiast. Over to you.
Hello, everyone. Yeah, I think my voice is audible, right? Yeah. Okay. So, so like other talks, I am also covering that embedded devices, how you can make your own gadgets for your own reasons. So for now, I am going to present on HID exploiter. So let me brief about myself. So my name is Tarun Singh. I am a HPC engineer, that is high performance computing. So I am the part of a team that deploys supercomputers in India and around the world. So that is my profile. And when you deal with such big systems, so security comes in the concern. So taking care of that part. So I started making some of my gadgets that helps me penetrate those systems, and I can check the security of those systems. Okay. So just a quick disclaimer. All the information on this saga task are meant for developing defense attitude. That means this doesn't mean that you should hack or get involved in some kind of crime. So I'll insist all these information shall not be used for causing any kind of damage directly or indirectly. However, you can try at your own risk on your environment. Okay. So I think everyone has seen these devices. These are like pen drives, keyboard, USB charging cables, lightning cables, and mouse, etc. Right? So today in today's talk, we are going to use these hardwares to deploy some exploit and check the security of the machine. So what does HID exactly mean? So it is a kind of we call it human interface device. So that takes the input and output from the humans. So it was coined by Mike Van Penderen of Microsoft, and generally mouse, keyboard, charging cables. These are the most commonly used HIDs. So why we are considering these kind of devices? So there is a quote in security that humans are the weakest link in the security. Like we love three things. So whenever you are at airport or some coffee shop, so charging stations are there. So what we simply do, we take their cable and we plug it our mobile or will put our laptop on their free Wi-Fi. So these are the three things that generally people use. Other things are like pen drives. So nowadays, if you go to buy some kind of laptop or something, so they usually provide these three things like USB, keyboard, and mouse. They used to give it free. So like all humans, we love free things. And other thing is like someone lost and someone found. So even if you found someone's pen drive, so people used to have that mentality. They used to think it their own, and they started using that pen drive. So that is the weakest link in that security. And we also have human nature, that is, we call it helping hands. So if somebody asks you to get me, I suppose, get me a printout, or I want to upload these copies from my pen drive. So we don't think, mostly we in case we used to help those kind of people. So those scenarios we are considering here, and we try to exploit those parameters. So why we are using HIDs in pen testing? Pen testing is basically penetration testing, in which you usually penetrate a system. What all it has to offer you. It is like a house that is having doors and windows. So like a thief, you need to knock doors and try to open windows, and like, so this is a kind of penetration testing. So why we are using HIDs or human interface devices? So these devices are trusted by the operating systems. So generally, operating system, what it does, it usually load the uh, device, uh, uh, bootloaders and all, and they usually trust. And antivirus software don't care about these devices. So because these devices are generally controlled by the humans, so antivirus doesn't have control over that. And these attack scenarios are large in number, and they may have severe impact. So that you'll get to know after this presentation. So what does a Windows family operating system do whenever you put a pen drive or some kind of HID device? So what it does is a user got notified when a new device is connected, and it takes around 15 to 20 seconds to load the device drivers. And these devices are really fast. Like a USB keyboard buffer for Windows is huge, so they can type really fast. And if you are using PowerShell in Windows, so you have all the power. It means you can exploit a system in more many ways. And we consider the next family, that is OS X or Mac family. So whenever you connect these HID devices to your Mac, so the user is not notified generally, and it takes around 10 to 15 seconds for for the device drivers to load. And for Mac, so these devices cannot type very much fast, but a script like OS X is also a kind of Unix family. So various scripting languages are available, like Shell and all. So you can take advantage of those languages, and you can write your own payloads. So what we are trying to do, maybe I'll play a video. So So let me brief you about this guy. So this is Kevin Mitnick. He was the first renowned hacker in the history. So and he was on the top list of FBI, and now he has opened his own security agency, and he has started giving demos and providing service consultation services. So so just look this video. So
Sir, the audio is not available. Can you explain what he's doing?
okay, so I think audio is not coming up. So I'll explain what he is saying. So he is saying that so he is going to use that kind of pen drive that as a HID attack vector, and they have also created a wire, a charging wire, so you can take advantage of that. So I'll just play the video. Okay, so I think not coming up. So I'll explain what he is saying. So he is saying that so he is going to use that kind of pen drive that so like this cable he is using. So this is a micro USB cable. So there are two computers out there. So one is the victim's computer and one is the hacker's computer. So what he is going to do is he'll put this cable as a charging point, and uh, you can see what happens next. So once he connects the cable, so if you can see clearly, yeah. So PowerShell opens and it will load the payload, and the payload is injected, and yeah. So the other machine, that is hacker's machine, got the access to that complete machine. And if you can see, so that device is also charging. So it is a kind of multi-purpose wire. So you can hack through this wire and you can also charge through this wire. So what we are going to do, we are going to do here is, so we'll build this device, because if these devices are available in the market, but if you go and buy them, so they will cost you around $200 each. So what we are going to do, we'll build them in around $20 or $30. So tools we need a soldering iron, we need some tweezers, we need some cutters, we need pliers and all. And what we will be doing, we are going to make a implant on the wireless adapter of some keyboard or some mouse. So if you can see, so this is a Logitech wireless controller for a keyboard, and what I have done is I have opened it, and uh, like the instructions you can read. So we have connected two cables, one on VCC and one on ground. So once those cables are connected, and then you can put a hot glue and you can enclose that device. So now what we need to do is we need to upload the firmware. So there are open source firmware that are available, and you can upload your payload in there, and you are ready to go. So what I am doing is here is I'm flashing that controller for the keyboard and mouse, and and that should work. So this is how the screen looks like after, if you see. So I am uploading a firmware onto that device, a controller, and once it got flashed, so you are able to see here. So this is the version and all of that device. So and now you have created a device into that for that same task we have seen. So I'm not doing a live demo. I am going to show you the demo. So maybe you can see that demo. So in this scene, what I'm downloading a Logitech firmware that is available on their GitHub repo. So the firmware is known as Git Tracker, and it is done by April Brothers. So that is a open source firmware. You can download it, and you can flash your Logitech communicator. That is a USB dongle that is used for connecting keyboards and mouses. So once that is done, so I will flash that into my USB drives. And if you see the device manager, so you will see it here. So you can see it comes in the keyboard section of under device manager. So the payload I am using here is the WannaCry. That is a one famous ransomware. So I am using that, and I am flashing that into that Logitech adapter. So it is just flashing. So now it got flashed. And this is the payload for the WannaCry ransomware. So once I connect this device to some Windows laptop, so it will execute the payload in the run prompt, and the computer will be locked. So this is how usually it happens. So the people who don't have that idea that these things can also be done through these USB devices. So what is the defense for these kind of attacks? So for Windows system, if you are on some Active Directory domain, so what you can do is you can do the group policies, and you can prevent installation of removable devices. For OS X systems, so you can create the UDEV rules, and if possible, so if there are some kind of, if you see these devices on dashboard things, and then you can see on televisions there are USB drives like that. So you can block those USB ports on those drives. And the conclusion we got from this talk is like USB HIDs are real threat, and they are here to stay. If you are not aware of those attack vectors, so you are only responsible for that conduct. And operating system trust its users. So it is only on users. So and there's a code in security that security is incomplete without you. You need to participate actively on on for securing your machines. Yeah, thanks. Any questions?
right, sir. So now we'll move on to Q&A. So one of the questions that we had right now is what is your roadmap to becoming a certified ethical hacker?
So initially you can go for CEH, that is Certified Ethical Hacker. So that is the course you can do, and for that course you will learn all the tools you can use. So generally, what they suggest, like security is a kind of forest. So you need to search for a domain in which kind of security domain you want to go. Like for network security, you want to go for system security. So these kind of things you need to consider first. And once you took these things into consideration, then you need to do CEH. You can go for CISSP, you can go for OSCP. So these are the certifications available in the market. And for learning perspective, if you want, so there is a Indian company that we call as Pentesters Academy. So you can enroll there, and they have their labs there. The vulnerable labs are there, so you can try out on their labs, and they are really good.
All right, sir. So we have one more question. That okay. So is this why Android disabled MTP by default? So I'm assuming that
Yes,
earlier.
exactly.
Yeah.
Yeah. So earlier that happened 2 years back. So what things if that is enabled on your mobile? So like on Android, there used to be pin code of 4 digit. So you can break that four pin code by this attack in 8 hours.
Okay. So our last question is modern antiviruses such as Kaspersky and Icarus update their malware signatures on a daily basis. So how do we make sure our payload is well encrypted and unique?
So the thing is, you are not using. So generally, what these antiviruses do, they used to have their definitions. They have used to have their definitions database. So if that is found in some kind of application, so that will stop that application. But in this case, you are writing a payload on your system. Like I said previously, that operating system trusts you. These antivirus trust you. So what it does is, the operating system feels like that you are only doing your stuff. It doesn't have it don't care that what things you are doing. So antiviruses and operating systems will be having no idea that what is happening with the machine.
Okay. Okay, sir. So that winds up all of the questions that we have. So we'll wind up the talk with that. Thank you very much for
Okay,
coming.
thank you.
So much, Mr. Singh, for such a remarkable talk on embedded devices for pen testing. Adding to such amazing talks, up next we have a speaker who will be delivering talk on the topic going serverless. Please wait for a few minutes while we queue up the next speaker.
Kavita saying don't talk casually or something. Like the moderators itself. Yeah, that's right.
Speaker is Mr. Blesson George Vargas. He's the Tech DSC SRM, winner of 2019 Smart India Hackathon and the Google Explore ML Facilitator. It's a great pleasure for me to introduce Mr. Vargas. Over to you.
Hi everyone. Good afternoon. I hope I'm audible. Robin, am I audible? Okay. Hi. So I think it's been quite long since this conference has started. Nevertheless, we are gonna learn about serverless architecture now. And well, I'm Blessing George Varghese. I'm a fourth year BTech CSE student from SRM IST Chennai, and I'm a full stack developer. Right now, I'm doing my internship with Bajaj FinServe's HealthRx. That's a startup. Now, without taking much of your time, let's dive straight into our topic. So, is my screen visible now? Like Robin? Okay. Is it visible? Okay. So now we're gonna have a lightning talk. That's what we call it at conferences, right? We're gonna have a lightning talk about going serverless. So we won't be having a live demo of it, live functioning demo of it, but rather we'll be going through ins and outs and a short intro of serverless architecture and how is it gonna help us. So if you want to know more about me, you can always check out my profile at www.blessingspeaks.com. And let's start. Well, before we go directly into serverless, let's understand some basics, right? Now, trust me, I won't take much of your time on this, but it's always good to start from basics. Now, consider this ideal situation, right? I've been here, you've been here, all of us have been here when we started programming. We made a C++ or Java or C or any language. We made a program or even Python. We made a program that said a equals 2 plus 3, return a, and you got the output that is 5. That's perfect. Fine, that's the basics. That's the basics where we all started. And now, Robin, on a side note, if I'm not audible at any time, please to tell me, okay? Or if I need to. Okay. Okay, this is the basic case we all began with, right? We started with a basic case where we ran the program on our machine, we got the output, and we were good with it. But then that's not fit for an industrial use case, right? Well, what's the difference? Consider this case where you have a program running on your laptop or your PC or wherever. It returns a program, but not to you. You need the world to use it. You need other people to use it from remote locations. You need other people from around the globe to use your application and be consumers of it. How will we do that? Right? Now, there is a missing link between you who is sitting at your home and the other people who are sitting in different parts of the world. How will you deliver content that you have made to other people? Now we have to fill in this particular part. We have to fill in an answer for this question mark, and that is cloud. Now, I personally find this meme very much interesting. So a person says that I found a free hosting service. Then the second person asks which host, and he answers localhost. Today, this is a meme. We make fun of it, right? We crack jokes around this thing. But this was not the case 20 years back. If you don't trust me, take an example. Okay, read from the second one. Okay, unable to afford a high-speed internet connection. Musk, that's Elon Musk, ran the website. That's his first venture on his PC using a dial-up modem. So essentially, he converted his PC's local host into a web server, right? And this is not any random guy. This is not any Dick and Harry. This is Elon Musk, right? And Elon Musk used to run his application from his local host. Now, this meme is a meme only for now. Earlier, this was not a meme. But now this is not feasible. Even Elon Musk would not be running his applications for Tesla or for SpaceX from his local host. Why? The tech has changed, and for a better demand, we can't do it anymore. So how do we do it today? Today we run it on the cloud. And what is this cloud? Well, the cloud is nothing but it is someone else's computer, either Google's or Amazon's or Microsoft or Alibaba, someone else's much powerful computer with a better networking capability and power backup. That's it. So if you have a rack of your laptops, or we were having discussions about Raspberry Pis, right? There are even people who set up servers using Raspberry Pi and use that as a cloud server location. So if you could rack up a couple of serving spaces, Raspberry Pis or uh, Windows machines or Ubuntu machines with uninterrupted power supply and better network, that's cloud. That's it. So that's nothing, rocket science. That's basically computers with uninterrupted network and power supply. Let's go forward, and if you look at the screen right now, you'll see a lot of topics, right? You'll see a lot of random terms. I'm pretty much sure all of you have at least heard of two out of these, right? Some of you might have heard about all of these, or even more than this, but I'm pretty much sure you have heard of at least one or two of these. Now, all of these are some way or other way they are related to the cloud infrastructure. Now, all of them does not mean the same thing, but the entire cloud ecosystem is consisted, or is built upon most of these components. Now, all of these are not mandatory, or some of these are optional. We're going to learn about serverless architecture. Now, if you look over here, I have put a wildcard star AAS. That means that star could be replaced with P, I, A, sorry, S, and all the stuff. What does that mean? It could be software as a service, platform as a service, infrastructure as a service, DB as a service. So essentially, someone is hosting a service somewhere and giving it to you over the cloud. That's a very interesting topic, but not for today. Let's, as I told you before, let's dive straight into serverless architecture. Yeah. So, to be honest, when I heard the term serverless architecture, right? When I heard it, I was a little bit of confused. I was confused. Serverless architecture. So, do you mean that we don't have a server? Like it is not hosted somewhere, but it is working. How is it even possible? I was literally, confused by this term. What do you mean by serverless? Is the absence of a server? Well, it's not the absence of a server. Let's find out. Yeah, before, okay, I think the screen is cropped a bit, but not an issue. On the left side, you have what? WHAT, what? Okay, first I'll answer this question. What is serverless architecture? So, I'm telling you an overview, okay? The things on the right side, that's not 100% true always. Now, this is for the general case. For a better understanding, you can consider serverless architecture as a place where you deploy functions. So you don't deploy applications on serverless architectures usually. You create an independent function that can execute a single task for you. So that itself gives an idea that serverless functions are used for smaller use cases where you don't do heavy lifting. Not an issue, we'll come back to that. And the resources are dynamically allocated. What do you mean by dynamic allocation? So usually if you go for a VM, virtual machine, or a container, you say that, okay, I need 2 gigabytes of RAM, I need 4 processor cores, and all the stuff, right? But for a serverless function, you don't say that. It scales from the lowest possible amount of RAM to the highest available amount of RAM, to the lowest number of cores of CPU to the highest available. Now, how does this help us? We'll see that in the upcoming slides. And serverless architecture is usually used for APIs. And I hope all of you are familiar with the term APIs. APIs can either be graph based or REST based. And as this is an IoET conference, Internet of Everything, which includes IoT as well, API, so IoT minus API usually gives you nothing, right? If you can't make network calls, IoT won't simply exist because you're removing internet from there. So network calls is the soul of IoT. And why are we learning serverless functions? It makes your life easier if you're dealing with IoT or IoET. Okay, before we learn about anything, right? before we learn about it, we should have a clear-cut answer to why we are learning it, or else there's no point in learning it. So let's answer why should we know about serverless. Even if you don't use it, it's fine. But you should understand in which use case or why should you prefer serverless deployments. But to understand this better, let me give you a better picture. So these are four different architectures that you can see. Now these are not the this is not the total picture. Okay, there are more ways to deploy anything, but these four, or at least the first three, are common ways in which you deploy your APIs or your applications. Now, as I showed you in the demo, Elon Musk initially preferred on PC deployment. Now we all know that that is not feasible. You're not going to run your API for the public from your own PC. That would be dumb unless you own, you own a cloud service scalable PC or an infrastructure, something like that. Let's look at the second use case. So in the second use case, we have a virtual machine on a cloud, which is a pretty good, traditional way of deploying applications. You spin up a VM. Robin, do we have questions in between? Like, okay, okay, guys. So to keep up with time, we'll take questions at the end. Back to our topic. VM on a cloud. This is not outdated. Okay, VM on a cloud is not a stupid idea, contrary to what many are claiming. VM on a cloud infrastructure is a totally valid deployment architecture for many of the use cases. But it's just that for certain use cases, there are better ways which are listed on the right side. So container is one of the best ways, container along with Docker. So I'm not diving into what is Docker and all those stuff. I assume that you have got a glimpse of Docker from Ajit sir and all. Or else, Docker is a huge in-depth thing to be covered in such a short lightning talk. Container basically is a stripped down version of your operating system which supports only which has bare minimum resources to run your application. Let's go to our own topic, right? Let's focus on our topic, serverless functions. Now let's consider let's compare. When you run an application, let me give you an example. I need to deploy an API which returns me the weather, the classic example, the weather at my hometown. So I give it the pin code of my hometown and the API returns me the weather at my hometown. As simple as that. Now you need not think about how will we code it, which language will I use, will I put in Node or Python, leave all that. Okay, we are looking at only the infrastructure level concepts. So the input would be my pin code, get request or post request or anything. I will give the API my pin code, and the API should return me the weather at my location. As simple as that. Now, if I deploy it on a VM, that becomes very expensive. Why? I can't just deploy an API on my VM, right? First of all, my VM should have an OS. It should be Windows or Ubuntu or any other version of Linux or whatever OS you choose. That it should have an OS. So OS itself will give you a bare minimum requirement of at least 1 GB of RAM. So now you have 1 GB of RAM. Now you need your Apache or Nginx or something to run if you need reverse proxy and all those stuff. But at least you need 1 GB of RAM on a VM to run a simple REST API. Now you need at least one full processor core. Why? Because you need to run your OS as well, right? Now, what are we losing out over here? What is our focus? Our focus is to deploy an API. But instead, what are you doing right now? You're managing an OS. That's the issue with a virtual machine. You have to do much more than actually what you need to do. Moving ahead to container. How is a container different from a VM? You have only those particular services which are required to run your REST API. For example, you won't have a display driver. Why? A server that is serving to API request won't need display drivers or sound drivers and all those stuff, right? So, for example, you have Slim OS of Linux, which is very famous if you go to Docker. Slim is, I guess, if I'm not wrong, it's around 82 MB. So the OS itself takes only 82 MB. But again, let's say, okay, I'll add one more condition to my API call, okay? My API will be called only twice a day. Now, there could be two time calls. Either I can specify the two time slots in which it will be called, and my VM and my container wakes up only at those two times. but the issue is different. I don't know, but my user will call my API at 2 point of time in a day, but I don't know when will he call it. Now comes the issue. My VM and my container, both these will be running round the clock, and that will add to my billing. Why? Even if I have zero users on my network, my service is still running. So I have to pay for unused resources as well. Now that's a very bad thing, right? And scaling. VM, ideally scaling and VM, they don't go in the same picture because VMs traditionally cannot be scaled. Containers you can scale, that's we have Kubernetes and all those stuff. But again, you are introducing infrastructure. As a developer, what should be our focus? Our focus should be on the code and on the logic. For example, if you are developing a geofencing IoT network, why should you know about Kubernetes and all those stuff, right? I mean, it's good to know, but it's not it should not be a necessity to know. That's where serverless functions kick in. You just write one particular block of your code, you deploy it, and that runs. That's it. And what's the advantage? Your code runs only when your application is cold. So if you have zero users, your application is not running. Now you might be thinking, hey, how is that possible? That is called as a trigger. For example, you can, if you are a web developer, you can compare that to web sockets. This is not web sockets, but you can compare that to web socket. There is a listener service provided by Google or AWS, your Amazon Web Services, or Azure from Microsoft that listens to a call. And when they listen for a call and they get a call, then they wake up your API. And once your API call is done, you return back the response and your API sleeps again. So you don't pay for the time when you have zero users. So that's a huge improvement in cost effectiveness. Now let's take the other extreme. You're having 10,000 users at the same time. So your VM will simply say that, oh my God, this is too, this, I have too many users. I can't serve to all these users. And virtual machine is not something that you can add more RAM on the fly without turning it off and on. Container, there are ways to scale it up, but serverless, you need not know about it. It will auto scale. So you literally don't care about the number of users that you're having. You just care about the code. Everything is managed. Okay. Yeah. Now we have a couple of ideas about that. Now we'll answer the question that we had earlier. Why should we go for serverless computing or serverless architectures or functions? First point, it allows the developer to focus more on the code and less on the deployment. Second one, hassle-free scaling. Now, scaling is a big thing. If you're from SRM or if you're from any other college, I'll give you a good example for this. When you try to book your hostel or when you try to take your choose your faculties in SRM, or let's say when you try to see your 10th class results from CBSE or 12th class results or JO, whatever, when the result is announced and you try to log into it the very next moment, I'm pretty sure you won't get it. Now, why does this happen? This is one of the best examples for bad scaling. Trust me. The thing is that in the backend, they're not scaling the system. They're not adjusting the resources dynamically to serve the increasing demand from the user side. So, how does it affect the users? The system just says that I'm not sure what to do, so I'm doing nothing. So, your users simply won't get the resource that they're trying to reach. Serverless functions eliminates this thing by implementing auto scaling. What do you mean by auto scaling again? You adjust the amount of RAM, you adjust the number of processor cores allocated to your API. And as I told you before, why should you use serverless functions? You pay per the millisecond. Now look at the granularity of it. You pay per the number of milliseconds for which your app is running. So if your API is running only twice a day, for 100 milliseconds each, you pay only for 200 milliseconds a day. As simple as that. Whereas this is not possible in the other cases, right? Now, there are both pros and cons to it. Initially, let's focus only on the pros. Coming to next slide. Okay, now we answered two questions. What is serverless function What is a serverless function? Why should we use a serverless function? Now let's answer this question. How does this thing actually work? How is this entire picture being painted, right? First thing, as I told you before, there is that event-based trigger. Now, to put it into simple perspective, consider your mobile phone. All of us must be having an Android or an iPhone. I don't, okay, whatever it is, you must be having a phone with a lock button, right? That's enough. There are two ways to keep your phone on the table, right? Either you lock it or you switch it off. When you switch it off, the time taken to get it back to your working condition is significantly more than your locked condition, right? If you're from ECE and if you have got some basics in it, you must be aware of a thing that microprocessors have a thing called as power states, S1, S2, S3, or something. Some process might have S4. It's optional. So keeping that aside, so power states basically tell us that your API or your service or your device is in a power state that consumes lower power and can be resumed faster. There are some power states like that. Let's go back to the example of a mobile phone. Consider my mobile phone is locked, but does that mean that I won't get a call? No. So there's a tiny listener service inside my mobile phone that listens to a network call for an incoming call. And when my friend, for example, if Robin calls me right now, my phone is locked right now, but that doesn't mean that it can't work right now. When if Robin gives me a call, that listener service will make an event-based trigger to the OS saying that hey, there is a call coming up. You have to turn on power supply for your speaker, and also you have to give it a haptic feedback, so make some vibrations also. So this is happening in serverless functions as well. Your function is actually sleeping, but it doesn't mean that you can't trigger it. You can trigger it remotely, and then once the trigger is made, we go to the second point. The cloud service provider invokes your function. Now, who is a cloud service provider? It could be Google with GCP, it could be Amazon with AWS, it could be Microsoft with Azure. There is Alibaba, Netlify, there are Heroku. You have a lot of cloud service providers. So once they get the trigger, they invoke your function. Then you return something. You return hello world, hi Robin, hi IoET conference. You return something. Then once you return, your job is done. So comparing to the phone call that Robin made to me, I hang up the call, put my phone on my table, it goes back to sleep. Now, similarly, my API returns the response, then it comes back and sleeps. How does it help me? Similarly, in a similar fashion to your phone, when it is locked, when the screen is locked, you're conserving power and it is improving energy efficiency for your phone. Relating the same scenario to your serverless functions, we are saving cost over here. We are not paying for the resource because we are simply not using it, right? Going to the next slide, we discussed a lot of pros of serverless functions, right? There are some cons to it, as we have cons for everything, right? You give me anything, I can tell cons about it. I'm pretty sure you can do the same. So cons, the first con or first negative point of it is that it won't simply let us to use private networking. Now, why do we need private networking? As this is based on IoT, see, private networking is something that could be important for certain projects. You have to have local interactions. I'll give you a simple example. If you connect 5 different mobile phones to the same Wi-Fi network, you don't need internet to talk to these 5 networks, right? You can talk to them privately. I mean, using the local IP address. But when you deploy a serverless function, it's usually deployed over an API gateway. Now, API gateway is out of our topic. I'm not going over there. But you get a public IP address, sorry, public domain with it could be a subdomain or it could be a public domain for your function. So you can't talk to it internally. You have to go over the internet to talk to your function. That could be a bummer somewhere where there are companies who restrict access from for the public internet to certain APIs. But for normal projects that should not be an issue. Second one, timeout. This is one of the biggest issues with serverless functions. Just because that it is economically efficient, it is scalable and all those stuff doesn't mean that it can run forever. They usually you have timeout limits. It could be 10 seconds, it could be 120 seconds. Usually they keep it at around, Firebase keeps it at around 10 seconds, I believe. So once your event trigger is made, your function should return the output within 10 seconds or 20 seconds. So there is a value X, okay, which is kept as a timeout by the cloud service provider. That simply means that you can't make your function run for more than that amount of time. Let's say I have 10 seconds as my limit and my function takes 12 seconds. On the 10th second, I'll get a response saying that your function failed because of timeout error, whereas my function actually has not failed. But the platform made a restriction that you should run your function only for this amount of time. Now, is this actually a negative, point for or negative point that comes with serverless functions? No. Why? Serverless functions are never meant to be executed for a long time. As the name says, it is event based. And when you talk about event based APIs, it is supposed to get a response, process it, and return it instantly, almost instantly. So usually timeout won't be an issue for IoT. Why? Because IoT mostly it's like, hey, I pressed a button, you have to change it over there. Tick tock. That's it. Or this person moved out of this geofenced area. That's it. Where does this come into picture? Take the case of machine learning. There are two things to machine learning, right? You have inference, where you ask the model about the information about an object. Then you have training. Now the first part is possible. Why? Asking an ML model what is this object is pretty simple. It won't take much of time. But training an ML model with an API call will definitely take more than 10 seconds if your dataset is big. So that is not possible. You can't make your function wait for a long time in serverless functions. Third thing is vendor lock-in. Now this is more to the business side of it, okay? So I've already told you can deploy your serverless functions in GCP, Google Cloud, Azure, AWS, or anything you would like. But the issue is that the code set or the code base written for AWS can't be used for GCP directly. The code base written for GCP can't be directly deployed onto AWS or to Netlify. Each provider has their own ways of running cloud functions, sorry, serverless functions. So that is kind of a locked in situation, but it does not mean that you can never back out. You have to change your code base to migrate to a different provider. And this is because all these cloud serverless architectures, they're proprietary to that particular service provider. We'll come to that. Yeah. So AWS provides you a platform called as Lambda. Azure provides you a platform called as Azure Functions, and GCP provides you Google Cloud Functions. This is why vendor lock-in happens. These three, they don't provide you the same platform. Even though all three platforms give you the same facility, the architecture for these three platforms are kind of different on their side. So you can't take a function that is deployed on AWS and copy paste that to Azure, and from there you can't copy paste that to GCP. There is a minor change that's required. Now, enough of all this stuff. Let's see how a real world application with a front end, a database, a storage bucket, and a backend could be deployed over serverless functions or serverless architecture. Now, consider this as my E library, okay? When I say E library, this basically allows you to get your PDFs of ebooks from the front end that is stored in the storage location over here. And this database basically keeps an account of all the passwords and usernames and user login profiles, all those stuff. So when I load my front end over here and I type in my username and password, I press the submit button, right? Or I press the login button. At that point of time, this particular function is invoked. Only then. So then it goes to the database and checks if this is a valid user. It returns yes or no to the front end and logs me in according to the response provided. Now the fun part is that after this response has been given, this function sleeps again. So this won't wait for the user to press the next button. It will sleep. So it's not waiting for the user, it does its part and it sleeps. Now, once I'm logged in, okay, I click, I search for a book and I click on download that particular PDF. Let that be, the art of the deal or some in random book that you like. So I search for the book and I get the response from these two functions. There are two functions to it. It searches in the storage, returns it to the front end, and that's it. Now, what if I come back after 3 or 4 hours and request for another book? There will be another invocation made for these functions. These functions won't be running for the entire course of 4 hours for you to give the second response. So in short note, whenever you make a response, only then you invoke your function. Else you don't invoke your function, they're sleeping. Again, this helps you in reducing the cost incurred. Now, as this is not a live coding session, this is a hello world example, or you can say hi world example for a Python serverless function to be deployed over AWS Lambda. So when you invoke this particular function over here, it no, it won't return you hello from Lambda. That is print statement. It returns you hi. So I am pretty sure this will take around 100 milliseconds or less, and that's it. It returns and it clips. It won't have anything else to it. It won't listen for a stream change or anything. So guys, before wrapping up, in short note, how does it help us? It helps us to build highly scalable architectures easily. It helps us to make our application economically feasible by conserving resources when they're not used. And it also allows developers to focus on logic and code rather than infrastructure. Okay, yeah, thank you for listening to me. Do you have any questions? Now we are open to questions.
Blesson, I think you can see the question on the Google Meet page.
Okay, I'll take this question first. Are there any areas? Okay, before I get into all this stuff, I'm not sure if I'll be able to answer all the questions, but I'll try my level best. Okay. Are there any areas where going serverless is not secure? Now, this is a good question. I had this doubt in the beginning. Infrastructure wise, I don't believe that there is any security issue because Azure, AWS, and GCP, they have proved their secureness, and even governments use them. So infrastructure wise, it is pretty safe. But if your function is not safe, there could be a security issue. I'll tell you an example. Your function should ideally make use of JWTs, which are JavaScript web tokens, or else it could be invoked from even an unauthenticated location. So that depends upon our code. That does not depend upon the infrastructure. Or else you could even force CORS, cross origin resource policy. So if you put course, you can say that, okay, my function should be only invoked from this particular user, from this domain. So that security depends upon how you code it. It could be unsecure if you code it bad, and it could be highly secure if you code it good. Simply to make it secure, make sure you could use, now there are more ways to make it secure. You could implement JWTs, which is a common way of doing it, which verifies a token before accepting the request, which in simple words, it won't allow unauthenticated users to invoke the function. You have to be authenticated to invoke it. So I think that answers this question.
Also, I think the deployment also matters a bit, right? Where, like, in case you're using a Firebase oriented stack, you have to ensure that the Firestore policies and all are restricted
Yeah,
only to your
yeah,
function.
totally. I would agree to that. So if you're including database and storage buckets, what is storage bucket? It's a hard disk on the cloud, as simple as that. If you're involving storage buckets and databases, there are separate rules to be set for that, which are totally outside serverless architecture, premises. But as Robin pointed out, when you are coupling an API that is serverlessly deployed to a storage bucket, yes, you should make sure that only this API is allowed to call, read, write, delete, or update from this bucket, and who should have access to what. Only the admin should be able to delete it. user should be able to view it. There are rules for it or in all cloud platforms. Yeah.
Okay, so our last question. I think this is a fairly long one. Okay,
Oh, fantastic.
so
May I
I'll read
know?
it out for you.
Okay.
Serverless functions have cold start time. That is the time taken to set up the environment, download the code, make the database connections. When applications are not very active, that increases latency.
Yeah.
With such highly available and fast Node.js backend, why should serverless architecture be preferred?
Yeah. May I know who asked this question? If that's
I'm not
available.
sure. I'm the chat moderator sent me the question.
Okay. Fantastic question. Anyone who asked it. Okay. Yeah. So there's a thing called as cold start and hot start. So we don't actually call it hot start always. Okay. Cold start means, okay, come back to the example where I gave you the scenario where your API will be invoked only twice a day. Now, when you're not calling it, for example, for 8 minutes, if you're not calling your API for 8 minutes, it goes to a to a sleep state, right? I mentioned sleep state. It is more like a power conserving power state in your microprocessors. And then once your function is sleeping, and then if you make a call, if you make an API call, there will be an overhead time for the function to jumpstart, literally jumpstart, and then the function responds. Now the question is not why it happens. I understand the question is, in such a case, why serverless should be preferred. See, it all comes to the point where if you don't care about latency, but you are more focused on your ease of deployment and your cost per month, serverless should be preferred in that case. But if you need your application to have the highest response rate 24x7, irrespective of the number of users using it, go for a container or a VM. But if you're like, I'm okay with additional 200 milliseconds of time or 300 milliseconds of time, but it should be cost efficient and it should be highly scalable, then you should use serverless. It has got nothing to do with Node.js because Node.js is actually sleeping over there, and you have to invoke that to make it run. And that invocation period is the cold start time that's giving you an additional delay. So there is no hardbound rule that you should use serverless. It comes onto a point where you weigh cost efficiency or scalability over response rate. If you need the former, go for serverless functions. If you need the latter, go for a container or a VM. It all depends upon what you want more. What would be the priority for you?
All right. On the subject of latency, we can also say that just like a CDN ensures that a website is loading faster, can we also say that serverless functions have that advantage over a static single VM that is serving?
Definitely, definitely. That depends. That there's one more point to that. If you, for example, I'll take the example of Firebase. No, Firebase is a subsidiary of Google, or it is owned by Google, and I can say that it's a mini GCP. Okay, it has user-friendly versions of hardcore features inside GCP. So when you deploy a serverless function in Firebase, you can set up CDNs to deliver it across using Firebase hosting and all those stuff. So that allows you to, that gives an advantage over VMs. So it depends that, but this particular thing depends on the platform that you choose. So if you choose a platform without the support for a CDN, well, there's no advantage to it. But if you use something like Firebase, which supports multiple delivery locations, then yeah, that has an advantage. Now, when I say Firebase, that goes directly to GCP as well. Okay. Okay, I'll give you the short answer would be scaring, but give me 1 minute to answer this question. Yeah, I gave you an example that I faced. Okay, that I had 2 months back, literally 2 months back. I built an application that helps schools to deliver content. So keeping that aside, I had an API which when invoked goes to database, fetches content and delivers it back to the user. That's it. It takes two or three or four PDFs from the storage location, gives it back to the user. That's it. I ran it on a VM for 1 month on Azure, and my billing, that was a basic VM, Ubuntu VM, the beginner instance, and my billing was around 4,500 to something. It was less than 5,500 and above 4,000. It was on an average on that scale. I moved it to GCP, Google Cloud Platforms, Cloud Functions, and trust me, if you don't trust me, you can try it out your own on your own. Try running an API for 1 month in an API and in as well as in GCP. My billing went down from 4,500 to 120 rupees. Now that's a whopping discount that I got, right? So you would get the most economic benefit if your APIs are purely event based. So if your APIs run for more than 3 or 4 seconds, you won't get a benefit because you are built for the entire course of time. But if you're pretty sure that your APIs will run only for few milliseconds and you don't have users every second of your day, then you should definitely go for serverless functions.
Okay, Blesson. I guess that wraps up all of the questions that we have. Thank
Hmm.
you for your time. Thank you for
Yeah,
stopping by. The
yeah.
talk was great, and we had a lot of engagement in the comments. Okay.
Oh, okay. Thank you
Thank
guys.
you.
Thank you for listening with me.
Thank you.
Thank you, Mr. Vargas, for such an amazing talk. It was truly inspiring. So, moving forward, we have our next talk on
Okay.
object
എങ്ങനെയുണ്ടായിരുന്നു?
classification through a neural network's eye.
Okay.
Please wait for a few minutes
Okay.
for
Okay.
us
Okay.
to
Okay.
queue up the next speaker. Mr. Aditya Jyoti Paul is the founder of CAR, Google Explore ML Facilitator, and Facebook AI Scholar. It's a great pleasure to have you with us here, Mr. Paul, and without any further delay, over to you.
All right. I'm Aditya Jyotipal. I'm the founder of Cognitive Applications Research Lab. Is my screen visible? All right. I am Aditya Jyotipal, the founder of Cognitive Applications Research Lab. I have worked in AI for about the past 2 years. These are some of the organizations I had the fortune of being associated with. To find out more about me, there would be some links at the end of my talk, so you can ask me any questions or connect with me after the workshop. So today's talk is about machine learning and specifically object classification. So let us first of all understand what is machine learning. I'm pretty sure all of you might have heard about machine learning in some way or the other. There are a lot of definitions of it, but the common understanding of it is that you feed the machine some input data and also the labels which are associated with the input data in supervised machine learning, and only the input data where the machine finds some patterns on its own in unsupervised machine learning. So the object classification which we would be doing today is supervised machine learning, and this is a clear demonstration of like the differences between supervised and unsupervised. On the left part of my screen, you can see some stop symbols and which also have labels associated with them. On the right side of my screen, you can see some figures or some symbols which have maybe a triangle as a border or an octagon as a border, etc. So the machine would probably be separating the first two images from unsupervised into one cluster and the other into another cluster. So that's about supervised and unsupervised machine learning. There's also something called semi-supervised machine learning. So what happens here is you have a lot of data, and semi-supervised is somewhat of a vaguer different class of machine learning in which probably you would be adding some labels on your own by hand and then training it or giving the machine some idea from human expertise, and then the machine would go on to use that level of expertise on unsupervised and then learn better intricacies of the data. Alright, so we would only be focusing on supervised machine learning today, where we have both the images, which are the stop signs here, and the labels. So in supervised machine learning, one of the tasks which you can do is classification. There are many tasks like regression, classification, style transfer, etc. So one of the tasks which you have is classification, and among classification we have something called binary classification. What binary classification is, it talks about differentiating between two simple classes of data, like people who have cancer and people who do not have cancer, people who are male and people who are female. This sort of a clear distinguish ability. When we give this impart this to a machine, it's called binary classification. We also have something called multi-class classification. What that means is when you are say seeing an object and you say that it can be a cat or a dog or a truck, and your options are say more than two, maybe thousands, 10,000s, millions, etc. So in our first demo, we would actually be using a neural network which is trained on such sort of a classification algorithm. And also we have something called multi-class, multi-label classification. When you see the second image on my screen here, this is an example of multi-label classification. See, if you obviously this is a cropped out picture from a larger image, but if you see this cropped out picture, what would you call it? Would you call it a lion, a wildlife, a mammal? Because it's all of the above. So if you just call it one of them, it won't be very appropriate. So we have something called top K classification, which is used for multi-class, multi-label classification. And here it's obviously a lion. And the second label is wildlife because it is an example of wildlife and the mammal as well. So I hope this clear distinguishing ability between multi-class and multi-label classification is clear. If you have any questions, you can post it in the YouTube live stream as well. I get to see them and I would answer them at the end of this workshop. So one of the most popular ways about how we implement a classification algorithm is using neural networks. We could obviously use something called a rule-based approach as well. But the issue here is that maybe for binary classification, a rule-based approach would work. For example, if you were to distinguish between a square, a simple square on your screen, or a simple line on your screen, using a rule-based approach would be much more efficient and better than machine learning because the rules are simple. But now, even just if we're talking about cats, there are so many types of cats and so many types of dogs. Some breeds even look like one another. So it becomes very difficult for a machine learning engineer to write rules for all of these. And that person would actually have to write thousands or even more rules per class. And when you're processing thousands of rules across thousands of classes, that would lead to a worse performance than machine learning. So here we actually have to understand the differences between rule-based and machine learning. Rule-based approaches are suitable when you have a simple task at hand, when you have very less data, and machine learning is good when you have a lot of data and the task is more complicated than something which a simple rule-based approach can do. For example, if you were to alphabetize a list of song titles, it would be a rule-based approach. If you were to sort some words in a list, that would be a rule-based approach. But if you were given some pictures of cats and dogs and told to distinguish between them, that in that case, it would be more smarter to be using a machine learning based approach. And on screen, we have something called neural networks. In each of these layers, we have some weights which are getting trained. And I won't be actually going into how back propagation works or what the math behind this machine learning is. That would be out of scope right now. But I assume that we'll actually see how to deploy an algorithm or a neural network which would be using transfer learning to distinguish between cats and dogs. I will also be talking a bit about transfer learning and about what it is, how we are going to use it, and use that in the first part of this demonstration. All right, so assume that you have thousands of pictures of cats and thousands of pictures of dogs. And what can we do as an engineer to solve this problem and distinguish them that these are cats and these are dogs? All right, imagine that we just have the pictures and no labels. It would be a clustering problem or an unsupervised problem. But in this case, the case which we are looking at, we also have the labels of all of these cats and dogs. So what we do is we take this picture and the labels and we take out some of that data and we keep it aside. That is called a testing data set. So for example, imagine we have 1000 pictures of cats and dogs which are mixed together. But in each picture, we just have either one cat or one dog. Now we take out say 900 of those images and use that for training, and for the other 100 we use that for testing. So we train our algorithm, we get some testing data, some accuracy metrics. We see that we are not reaching very good levels of accuracy because we trained on just 900 images. That was not enough on to teach our algorithm all the intricacies of all the cats and dogs in the world. It could also be that because of our limited data, we did not actually provide a proper or a wholesome representation of our classes to the machine learning algorithm. So what we often do is we take some algorithm which has been trained on millions or even billions of data points by some company like Google, OpenAI, or Microsoft, who had the capability of training it on such huge data and such huge architectures. So here we see on the bottom left of my screen, we have something called source data. All right, this is the data which those companies use to train, and the source model is the architecture. The huge, enormous architectures which have hundreds or even like or close to 1,000 layers, and they have trained this the first to the source data and the source model. So they trained their source model and the source data, and maybe they were doing some multi-class, multi-label classification like image. So obviously they had thousands of labels, but our goal here is to just train an algorithm which can distinguish between cats and dogs very fast. So here what we are going to do is we are going to take their model, we are going to feed it our own data of our cats and dogs. We are going to train the last few layers of this neural network, and then we are going to remove the top layer, which, for example, let me go back to the previous slide. Here you see that in the last layer there are 10 output neurons. So if you're just classifying between a cat and a dog, you don't need 10 output neurons in the last layer. Just one output neuron with a sigmoid activation function would be enough. What we now do is we cut off the last layer, we keep the previous layers as is, we add a sigmoid neuron in the last layer, and we are good to go. We are also going to actually demonstrate how using transfer learning is actually a much faster and reliable way of doing machine learning. So I'll move to another screen right now. Here I have taken the liberty of running the code on my PC beforehand, because otherwise it would take about 6 minutes and 6 minutes to train for the two batches of code on which I'll be training. Alright, so let us understand what transfer learning is, or how we are going to apply it. We're firstly going to do two things: feature extraction and then fine tune. In feature extraction stage, that's the actual beauty of transfer learning. The features have already been extracted. The feature maps, for example, for edge detection in the previous layers of the neural network, have already been extracted, and that is by the companies. And when we load those weights into a neural network, we already have those trained feature maps, and it can easily identify between cats and dogs using those maps. Let's see how we can actually use that in this live demo. So what we'll do is we'll import some basic libraries, and we'll import TensorFlow. The data set which we are going to use for this cats versus dogs classification is there in TensorFlow datasets. It's called cats versus dogs. I'll be explaining the code as well as I go through. So here we see that we have extracted this or downloaded and extracted the dataset with tfds.load. The dataset name is cats versus dogs. It has been split into train, uh, validation, and testing. Don't be confused by the writing train colon 80% train and train here. All it means is that for your data set, the first 80% is for training, 80 to 90% is for validation, and the last 10%, 90% and above is for testing. With info means the metadata would be coming in as well. As supervised means we will be downloading the labels as well. So now it's unpacked into a tuple for raw train, raw validation, and raw testing. This is our raw data and the huge size images which we will be rescaling and doing some pre-processing on as we go. The metadata is the labels and some data about the data which we won't be using right now. So all right, let's see what the shapes and sizes are. We can see that we have uh, an encapsulation variable here, which has the shape of none comma none comma 3. So each image has 3 channels, and each image, obviously, what is an image? An image is a representation of the information in front of the lens of the camera. And how do we represent, or how do we approximate what is in front of the lens of the camera? We take some numbers between 0 and 255 and place them on this. Imagine we have something like a cuboid in front of us, which has say 256 rows, 256 columns, and depth is 3. So on the first layer, which is say your R channel or your red channel, you have 256 cross 256, which is 65536 values, and each value can range between 0 and 255. And to represent a value between 0 and 255, we use the data type unsigned integer 8, because 2 to the power 8 is 256. Alright, so I hope this is clear, but if you want to ask any questions, feel free to ask that in the chat section or the YouTube comments. Get label name. So here we are doing is we are using the metadata to extract the labels of the cats and dogs. So here we see that on my screen, you see that we have this text written above the picture, dog, and here we have another dog. All right, after this, we have something called format the data. So here we are defining our image size because we do not want our images, every single image to have a random size. For example, see in these two images on my screen, one of them has a longer length, one of them has a longer width. But when you're training it to a machine learning model, what we'll do is we need a fixed size of an image because we will be running a fixed number of convolutions in the first layer itself. Or even if you do not have some convolutions, if you're using, say, a deep neural network, we'll be flattening the image and then using. So we need to have a fixed input size. How do we do that? We rescale the image to 160 cross 160. So here we see that we have used tf.cast to cast the images to float 30. The first step, the casting is required because otherwise whenever you do the second step by 127, all the values would become almost all the values would become 0 or 1, which are integer values. The integer would only be between 0 and 1. Now you see that all the values in my image have been rescaled to a range of -1 to 1. So how do we calculate this range? The minimum value of an image would be 0. So you do 0 minus 1, which is -1 is your starting range, and your maximum value an image can have is 255. So if you do that calculation, 255 by 127.5 minus 1, you will get 1. So every image has now been converted to a scale or a range of -1 to +1. Why do we do this? Because it helps speed up our gradient descent steps in the next part of the algorithm. Then we're doing a simple resize. The shape is 160 cross 160. It's provided in as a tuple. And this format example, this is the complete pre-processing that we had. It's converting our images and returning it with a label as well. Alright, so now that we have this function to format our examples, we have to format every single example that we have in our training, validation, and testing, which we see here. Again, we do not want to train sequentially on the data because it could so be that all the images, the starting of the data set are cats, and then we have all dogs. So if our algorithm sees only cats in the first few epochs, it won't learn anything. It will just understand that every image which comes in as an input is a cat, and then it will learn that every image which comes in as an input is a dog. So anyway, we are not going to take any risks. We are going to use a batch size and a shuffle buffer size. So a batch size is that for taking every step in gradient descent, it will take 32 steps inside. 30. It will. I'm sorry. It will read 32 data points or 32 images. A shuffle buffer size is it won't search for these 32 images in the complete data set that we have, but randomly pick these 1,000 data points in advance, and in parallel use randomly select 32 of that 1,000 data points, and that 1,000 data points will be changing across every epoch. So you see that we have created some data generators here: train batches, validation batches, and test batches. I'm sorry, we just created those batches, and now we will be seeing the shape. So this, in Python, the pass keyword means that we are not doing anything inside. But there is no easy way of actually seeing what's inside a batch without actually running that batch. So what we do is we read the batch, we do not do anything on the batch, and we just print its shape to make sure that we are on the right track. So here we have 32 cross 160 cross 160 cross 3 because we read 32 images. So the first value is 32. We read an image with 160 rows and 160 columns because we rescaled it. And all the images are colored images, so they have three channels, RG and B. Okay. So now we have image shape defined as this tuple, and we are making a base model, which is based on MobileNet version 2, which is the pre-trained model. We have downloaded the data, the model weights as well. You see it here. This is the way you download a pre-trained model, or when you're using transfer learning. So I'm highlighting it on my screen here. And you have mentioned weights is equal to ImageNet, and we have not included the DOP. As I was mentioning, the top would be probably classifying thousands of classes. We do not need that. So we threw away the top and did not download it as well. Now we create these feature batches on the base model, and they have the shape of 32,5,5,1280. We'll be having a clearer idea of where this shape is coming from as we go on. But for now, you can understand that we have each batch of size 5 cross 5. So now what we're going to do is we're going to freeze this convolutional base or the model which we just downloaded. We are not going to train it. We're going to set it completely to false, and we're going to see the shape of the architecture of what we just downloaded. Let me zoom out a bit because it's a huge model, obviously. Alright, so we see that we had a total about 2.2 million parameters, and we are not training on any of those. Now we're going to add a classification head, which is just going to be a simple one neuron with a sigmoid layer. But before we get into that, we have to add a global average pooling layer to transform these the shape from 32 cross 5 cross 5 cross 1 1280, which we have here, to transform this shape to just ending with 1280, to 32 cross 1280. To know more about what global average pooling is, you can check out the TensorFlow Keras docs. But simply put, it will pick out each of those 5 cross 5 values and take the average of those. So imagine you have 5 rows, 5 columns, so 25 values, and you have 1280 number of these. So what we're going to do is we're going to transform that to just 1280. This transformation is done with global average pooling when you're using a convolutional neural network. We also have something called a prediction layer. This is the simple sigmoid which I was talking about. Now we define our complete model, which has the base model which we downloaded, which has the global average pooling layer which we just added, and a final prediction layer. Alright, so we set our base learning rate as 0.0001, which is I think not the default for RMS law. At least for Adam, the default is 0.001. At least you have to train and test with these models. The best way to do this is see which one is performing better. You can use a larger learning rate like 0.01 or 0.03 for the first 1 or 2 epochs and then decrease it. You can use a decay factor here. For example, you can type it out like this: decay is equal to 0.01 or something. I'm sorry, 0.001. Decay has to be much lesser as it's a factor. Or else you could also use a callback in TensorFlow, which we won't be demonstrating here, but you can use something called a callback. You can Google how to use callbacks in Keras. The callback is called reduce LR on plateau. So it will be going on with a larger learning rate as long as it can. But when it sees an epoch in which the validation loss is not decreasing anymore, then the callback would come into action and your learning rate would be decreased. So this is what our model looks like. We initially had this shape 5 cross 5 cross 1280. Using the global average pooling layer, we converted to none, 1280. So there are 1280 outputs in the last layer. And finally, in the output layer, we have just one neuron, which is it's called dense, but it's a simple it's a neuron which is connected to 1280 neurons in the previous layer. So it would be learning 1280 weights, and it would also be having one bias term. So it has one more weight to learn. That's the reason we have 1281 trainable parameters here. It's very important to understand where or how these shapes are coming from so that we can easily debug our models. There are two trainable variables, the global average pooling and the dense, but that's not very important to understand right now. This was just a sort of testing to understand that the code which I had written was right. And we see that we have about 45% accuracy without any training. That's because if you randomly classify between a cat and a dog, you have 50% chance, right, of getting it correct. So anything between 40 to 60 is, I guess, a good approximation. It shows that our training testing split has been done correctly as well. So we see that our initial loss is 1.03 and initial accuracy is 0.45. Now we'll start training, but I have already done this training, so we won't be doing this because it takes about 6 minutes to complete. We start from a validation accuracy of about 97, and at the end of the first epoch, so just at the end of first epoch, with the we're using transfer learning, we can get 97% accuracy. And at the end of the 10 epochs, days is about 98.58. But can we do any better? Of course we can. So till now, we see that we have not actually trained the neural network in any way. We have just used the previous weights and we have trained just the global average pooling layer and the sigmoid layer, which we wrote ourselves as well. Now what we're going to do is we are going to take that big neural network that we downloaded that has some weights, right? So we are going to take the last few layers of that big neural network and we are going to train those weights as well. Also, for this training which we have already done, without unfreezing the last few layers, we can see that these are the training and validation part. Yeah. All right. All right. So as we just discussed that we had this training and validation curves for training just the last layer which we had coded on our own. So these are the curves and we see that the training has been going on pretty smoothly. There are no rough edges or anything. We can also add something like a batch norm and dropout. But if we use them, we would observe some discrepancies between training and validation curve because for batch norm and dropout, the the run the metrics the metrics would be better when you are testing it and worse when you're training it. The reason for this is both of these layers actually do not, how do I put this? The simplest way of putting it would be they are just turned off when you are testing it. But what actually happens is all of the dropout layer cells get activated in the last layer when training. So only say 80% of the data would be used and 20% of the data would be used for testing. So this would actually take a little while to explain. So I would skip over this. You can and should actually read the documentation for this from the Keras documentation. Now, coming back to the fine tuning, as I was saying, we are gonna train the last few layers of the big neural network which we just downloaded and change those weights which we downloaded. So how do we do this? First of all, we set the base model that trainable is true. So we set the entire thing as true, but obviously we cannot train the entire neural network. So what we'll do is we'll set the first 100 layers. So in Python, when you write colon fine tune at which is 100, the first 100 layers will be set to false. This trainable variable or the parameter here actually decides if a certain layer or a certain neuron would be trained or not. So this is basically it. We again compile the model and we see the summary. We now have 1281 plus this 1.8 million parameters in the first epoch as in this neural network to train. And training it does take some time. It takes about 8 minutes to train for 10 epochs. And we can see the result of the training. We started from 98.28 accuracy and we went on to 98.62 accuracy. And it can actually be improved even more. Once when I was running this, I reached 99% accuracy. No, I actually have another demonstration that would take about 10 minutes. Is that all right? All right. All right, so with this, we come to an end of the demonstration of transfer learning, and we'll be now seeing how to use layer-wise feature activation maps. I have already run this code, but apparently this runtime needs to be restarted. So if you have any questions for transfer learning, you can post that in the chat section. In another 10 minutes, I will be demonstrating how you can use this layer-wise feature activation map as a tool to find out when to use or what your neural network is seeing in every single layer as it goes through training. We won't be implementing a very big neural network for this, just a small neural network. We will be using a data set between horses and humans, again a simple classification task. You see that just like the previous time, we are dividing it into training, validation, and testing. Sorry, just training and testing. There is no validation in this one. And we have about 500 images of horses for training and 128 images of horses for testing and 527 and 128 for humans. And this is the neural network architecture on which we are going to train it on. You see that we have just 3 convolutional pooling layers, one flattening layer in which what a flattened layer does is it takes 25 of your neurons, or say whatever, say you have 5 cross 5 images, so it will take those 25 neurons and it will sorry, not neurons, those pixels, and it will cast them into a single 1D vector, and then you put them to a dense layer as well. So this is our architecture. Where did I exactly lose the connectivity? All right, all right. So all right.
Okay, I'm sorry about that. We had a connection issue. Aditya, you're back live. You can share your
All
screen,
right.
and your screen is being shared. You can
All right.
continue with your presentation.
So as we were discussing the power of this layer-wise feature activation map, what we did was I give a brief rundown over what part has been covered till now. I don't exactly know which part I lost the connectivity. Hence, so what we firstly did was we downloaded the dataset. We divided it into training and testing. There were 500 horses and 527 humans for training. Then we created the batches. This was the architecture which we had. The architecture comprised of 3 layers of convolutional and pooling layers, and then one flatten operation and one dense, and a final sigmoid for the distinguishing between the horse and the human. This is very similar to the previous demo, so I won't go into explaining why we are using sigmoid here. This is the final model summary that we had. We are training a model which has about 9.4 million parameters. And here we have compiled a model. Now we'll directly jump into this demonstration. Sure, sure. This is the final demonstration which has, we trained it on this images, and we now uploaded 4 images of horses and 4 images of humans. So we see that the horse too here has been misclassified as a human, and we are trying to understand why the machine made this mistake. So this is, see, the first layer had 16 neurons, as you can see here in the model architecture. The next layer had 32, and even then we had again another layer with 64 and 64. So we see that in the first layer we have 16, then 2 layers with 32 and 2 layers with 64, the convolutional pooling layers. So you can actually zoom in on each of these pictures by opening them in a new tab. That would give you a better understanding of by seeing which parts of the image are getting lit up and which part of the image is not getting lit up. Let's look at another image here. Say we pick up human 4, which I remember was getting misclassified. 4. So let's look at the image. This was the image. Obviously, it's getting misclassified because it has so many real humans. But to get a clearer idea, you can see that what the neural network is looking at each particular iteration. So in the first layer itself, if you zoom in, you can see that some of the neurons have just found out some background noise, which is the hair portions and the hands of the images. It was actually trying to do some edge detection, but it ended up doing something very different for this image. And this sort of an impression actually goes towards the horse, as we will see in the later part of this neural network here. So this code is available on my GitHub repository on github.com/freakyphoenix/explainablecv under this name, layer-wise feature activation map. Feel free to play around with this code, and I would take 1 minute to explain this code cell as well. So what we have done is we have found out the names of those layers here, and for every single layer, we are trying to put the previous layer's inputs into this model, and we are going to extract the image, if the effect of the image after it has been passed through that layer, and we see that that's called a feature map, and we are going to display those feature maps in this grid which we are creating here. So this is pretty much plug and play. You can basically copy this code, change the shapes around, and you can use this for any particular neural network. And we can also do this for any random image from our testing data set. So here we see that we have random the choice, horse image files plus human image files, and you can see how it's getting classified. So this is the image which was randomly selected. This is a horse, and it's correctly predicted it's a horse. And you can see that what the neural network is looking at, each particular neuron in each layer is looking at as it moves through. So this is how we use layer-wise feature activation maps. Now I'll get back to my presentation and quickly give a rundown of what else has been done in explainable computer vision in the last few years. So we had something called uncertainty maps, we had visual explanations, we had saliency maps. You can definitely look at all of these. The latest approaches have been on GradCam++, which is from IIT Madras, I think. You can see the differences between GradCam and GradCam++. Additionally, one problem was GradCam would give you only one single heat map, and GradCam++ is better at finding images which are small in the background as well. So some of the efforts have been post hoc versus anti hoc. Post hoc means which is done after the model has been trained. For example, the approach which you just displayed was post hoc. Model agnostic versus model dependent. So some approaches which work on some models and do not work on other models are called model dependent approaches, whereas model agnostic approaches work for all neural networks or approaches. Global versus local talks about whether it classifies it as the entire image or only a specific part, does it display heat map, etc. So this shows the research efforts which have been going on. So a brief rundown of the research efforts is that why we look for explainability is for better human trust, debugging, and legal compliance. We should always be able to explain who is responsible if an AI is going wrong, and human-based evaluation makes it much more easier and trustworthy. These are the resources for my slide. You can check it out. This would be put on YouTube as well, so you can get those links from there. All right, so with this, we come to almost an end of my presentation, and I would love to take any questions right now.
All right, all right. So let's go to Q&A.
All right.
So the first question that we have is, what will happen in the first model if we give it the picture of a horse?
For the first model, what Does when was this question
I
asked?
think it's
Like
part of your. I think they were referring to your
second.
first demo,
Okay,
wherein
so
you
the
were
cats
comparing
versus dogs.
different breeds of dogs.
All right, I understand. So, if you give an image of a horse and a cats versus dogs in a cats versus dogs model, you would find a random output. You're not actually supposed to give an image of a horse or any other class which is not in your output for testing, because that would not make the output very meaningful. But in case you can also do this, so what you can do is you can have an output neuron for cat or dog, or you can also have something for an unknown class. So for everything else, like it can include a truck, a guy, a girl, and a horse, and everything. So if that neuron is the most powerful, it can display neither a cat nor a dog. So you have one neuron for a cat and dog, and one neuron for neither a cat and not a dog. I hope that answers this question.
Okay, I suppose so. Let's move on to the second one. Can you explain why a CNN is more preferable than ANN neural networks for object and image classifications?
Yes, this is a very, very good question. The Of course, what we can do is we can always take an image and we can completely flatten it and we can feed it into a neural network. But the problem with that approach is it loses this ability to learn some feature from one part of the image and maybe apply it to another part of the image. For example, let's say that we have a person's face in the top left corner of an image. Alright, and in our training, all the images were centered, so the person was in the center of the image. Now, if you crop it or if you move it to the top left, in testing, it will fail. Because the neural network has only learned that whenever there is a person's face in the center of the image, it's a human. If it's not there, it's not a human. But using these feature maps which are learned in CNNs, you get this spatial flexibility. So wherever your image is, it will be able to correctly extract the features and predict it correctly. Also, another reason why CNNs are better is because it gives you some computational. It's cheaper computationally compared to training a deep convolutional neural network for the same level of accuracy. Okay, so these are the 2 points.
Okay, so the last question is how do you perform feature scaling on transfer learning convolutions?
For feature scaling and transfer learning, you have to actually go back and find out whichever architecture you are using, what statistics they use. All right. So whenever you are using ImageNet statistics, there are three values: uh, the mean, the standard, the mean variance and standard deviation, those values. So you have to download those values and you have to get those values and you have to apply that particular scaling which they did for training over your data set. So this is again a very good question. So for example, imagine you're gonna planning to use ImageNet and they have done some level of feature scaling for their training. Now you decide to do some other sort of feature scaling for your training. It won't work. It would give bad results in testing as well. So you have to download or find out over the internet what sort of scaling was done and exactly use that scaling for your training as well.
Okay, and the last question we have is if object recognition through CNNs is so powerful, why is reinforcement learning used more widely in self driving systems?
All right, this is an interesting question. I'll take it in two parts. The first part is asking about the power of CNNs. Actually, even in self-driving systems, we often use convolutional neural networks. The second part is why use reinforcement learning at all. The second part is actually see, a self-driving car's goal is not just to understand what is there in front of you. It's like say it detects that there is a truck there, it's a car there. That is not sufficient for it. It also has to develop some rules, like where is it going and why is it going. For example, in reinforcement learning, we develop rules to understand, like a car is coming at this speed at an intersection. So if it keeps moving at this velocity, after some time it will reach that point. So if I move at this speed, I would crash into it. So these are things which CNNs do not do. CNN will just detect the image. So reinforcement learning helps you to learn some of these rules without explicitly coding them in that sense. So that's the reason reinforcement learning is more popular for developing rules or for training self-driving car-based approaches.
All right, Aditya. Thank you for joining
All
us
right.
today. Thank you for sharing your
Uh,
knowledge.
Thank you for having me here. It
Yes.
was a great workshop. Thank you.
All right. All right. So with that, we wind up the session. Okay.
All right.
Okay. Thank you very much for joining us today.
Thank you so much for such a wonderful talk. It was great to have you here with us. And up next, we have a talk on decentralized IoT using blockchain. We will be Speakers for this talk are Mr. Robin Biju Thomas and Mr. Jairaj Roshan. Mr. Biju is the team lead of the project team and an IoT, cloud computing, and a JavaScript developer. Mr. Roshan is the tech lead of the project team and a blockchain and front-end developer. It gives me immense pleasure to introduce you both to the audience. Over to you both.
Just a second. Okay, so finally I'm on camera. So hi guys, I'm Robin. I'm the team lead of the project team and the manager, the stream producer of this stream, I guess. And with me is Jairaj Roshan.
Shreya's audio is, I think, up.
Jairaj, turn off YouTube.
YouTube?
I mean, you're listening to the audio from YouTube, right? You can turn that off.
No. I mean,
no, Shreya's
wait,
audio is gone.
No. Oh, okay, all right. So, good afternoon, everyone. So, welcome to the last talk of the conference. So, today we'll be speaking about decentralized IoT using blockchain. Okay. So, am I audible?
Yeah, you are audible.
All right. So, let's get into it without wasting any more time. All right. So, let's first talk about what is IoT, right? So, if you're if you're attending this conference,
Jairaj,
most probably
hold
you'll
on.
be.
There's a lag.
Yeah.
I'll cue you just a second.
Sure.
Okay, go ahead.
All right. So, continuing with the same thing, if you're attending this conference, most probably you'll be familiar with the term IoT, right? So, IoT stands for Internet of Things. So, at its core, it's basically connecting all of these devices that you have in your daily life to the internet so that we can integrate something, some smart functionality or something to it, right? Now, uh, all right. So, what is the current scenario of IoT infrastructure, right? So, if you look at the current IoT infrastructure scenario, be it any device from like any manufacturer, they all rely on a centralized communication model. So if say if you have a Google Home, it will be connected to Google server, and then whatever you do with that Google Home, it will always try and contact the Google server, right? So that is a centralized communication. All the devices, they go and communicate with one central database. That is your centralized model. Now, this is also basically a server client paradigm where all your devices are clients and they all contact like one central server. Now, another thing which happens is, so for example, again, let's take an example of Google Home. So you can have multiple things like smart lights in your home. And if you say, if you want to turn that on or off using your Google Home, so you can just say the command, okay, Google, turn on the light. Now, when you utter this command, what happens is the Google Home will take in the audio, it will process it, and then it will send a command to the server, which will again send a command to your light bulb. So what is happening is, even though these two devices are very close to each other, all of this information is going to a central server and then coming back, which means there's a lot of wasted bandwidth, and basically you don't really need to send the data to a central server, right? Okay, so let's talk about this thing called a distributed system, right? So till now, what the IoT infrastructure is, it's basically a centralized network. Now there's two different things, a decentralized network and a distributed network. So when we talk about decentralized networks, it basically comes down to who has control, like who has control over the data. So if we talk about centralized server, a central server will be present, which will do anything with the data, right? So you can have like again Google server, and that will take in data, process it, and do whatever it wants. Now in a decentralized model, you will have multiple of these devices which will act as servers basically. So you can communicate with any of them. right? And all of them have power over their own nodes, so they can do like they can process your data and everything. Now, when it comes to distributed networks, uh, it deals with location. So your computing platforms, are they in one place or are they located in like over a long area, right? So you can have a distributed model which has a centralized network, or you can have a decentralized network with a distributed model. So it's there's like a small difference between decentralized and distributed, which you have to be clear about. All right. So what are the problems that we are facing with the current IoT solution, right? So first of all, if you want to create any IoT infrastructure, which will go into like actual use, right? So what you have to do is you have to deploy a whole infrastructure. So obviously you will have networking equipment, you will have server farms, you will have centralized clouds. So even if you're deploying your own servers, say you don't want to use GCP or AWS or anything, say even if you're deploying your own servers, you'll have a lot of capital. Like you'll have to like there's a cost, there's an upfront cost to deploying a server, or you'll create your own cloud site. So there's a large cost that is attached to it. The second thing is in a centralized model, the centralized server, which takes care of all of the data. Now, if something happens to it, the whole network is disrupted, which means there's a single point that can fail. Now, this is very important as IoT develops, we see more and more devices which are getting connected. You can have healthcare devices, so pacemakers or BP monitoring systems. Or if we go even further, we can have like full hospitals which will have their own IoT systems. Now, if there's any disruptions, any small disruptions in this network, what will happen is it will cost lives, right? So you cannot have a situation which basically creates any kind of disruptions. So this is another problem which we face with a centralized network. Now, what is the solution? Right. So what we can do is we can create a standardized peer-to-peer network. Right. So a peer-to-peer network is basically where you have these different devices which communicate with each other. They don't go and talk to a central server, and then the central server talks to this. They communicate with each other basically. Now, this has major advantages in the IoT infrastructure world because, again, let's talk about that Google Home example again. Right. So you have a Google Home, and that directly connects to your light bulb. Right. So there's no central server. So you can have a scenario where you don't have to need to have an internet connection, or you can just speak. So the latency will be reduced. You'll have better privacy. You will have lower bandwidth usage, and a lot of these stuff, right? And as we continue to go towards a more a more a bigger IoT infrastructure, so what happens is the transactions, the transactions are basically the communication between two devices. They keeps on increasing. So we'll have hundreds of billions of transactions per minute, right? So in those cases, a centralized model will have a lot of problems, right? So if you have one server and it cannot scale well, as we heard in the previous talks, you'll obviously not get a good experience. So when it comes to an IoT infrastructure where you have devices close to each other and they need to communicate, what we can do is create a peer-to-peer communication network. Now, the second point is it should be standardized. So why should it be standardized, right? So right now, if you go and buy, say, a smart light bulb, so you'll have to see if that smart light bulb is compatible with Google Home or Amazon Alexa, right? So these are proprietary systems. They will have a certain set of APIs which you can include, but there's no actual way to like communicate a Google Home to like an Amazon Alexa. You'll have to go through a lot of APIs and everything. So that's why standardizing your communication models in the IoT world is very important. So if we have a standardized peer-to-peer network, what happens is all your devices can easily communicate with each other. Now, this is very important when you think about things like smart city. Like a lot of people are doing these research and projects in smart city. I think even in India has some projects, like the Indian government, they want to make some cities smart. Now, what happens is you have these different devices which need to talk with each other and they need to work with each other. Right. So you can have, say, a device which tracks the location of a bus, and then you can have a certain device which will show uh, the location of the bus on the bus stop. So all of these devices need to communicate with each other easily. So that can only happen when we have a standardized model. Right? So another advantage of using a peer-to-peer network is basically you don't have a single point of failure. Right, because there are so many different nodes, even if one of them gets damaged or gets corrupted, the network will still work just fine. It's just that that device won't work. So that what happens is that gives resilience to our network, right? All right. So if this decentralized model is so great, why aren't we using it? Right. If it is so great, then obviously everyone should be using it. Now, the first biggest challenge in using a peer-to-peer network is with security. So right now, with a centralized model, what happens is all of your data goes to a central server, and that is secured by the company that is providing it. So they are basically work like working as a safe to keep all of your data. Right? If you have a peer-to-peer network, the data can go to any person, and maybe they can tamper with it. They can change the data. Right.
Correct.
So security is very important when it comes to peer-to-peer network, and that is one of the biggest issues that we had with creating a peer-to-peer network. So another thing is called a cold start problem. Now, what is a cold start problem? It's basically like this. Say, okay, so right now, if you have a centralized model, you'll have like a central server, and if you buy any device, it will directly connect to it, right? So you can buy one device, you can buy 10 devices, they'll just start communicating with the server. Now, when it comes to a decentralized model, what happens is the network depends on how many people are actually using that network, right? So, so if a lot more people are using the network, what happens is the network is more resilient. It's better, right? You can have like the network won't just drop at any time. It will stay what you call away. So now, how do you get people to start using the network, right? Because initially you won't have any devices on this network. So you need people to start using the network so that the network becomes better. And if people will only use this network if the network is better. So you have this problem of balancing if how good the network performs and how many people are using it, right? So one of the ways in which one of the recent advances in peer-to-peer networking is called a blockchain, right? So what happened, okay, is basically that a blockchain is a tamper-proof ledger, right? So what happens is whenever you add a data to the blockchain, you cannot change it. So that is one of the biggest advantage that a blockchain gives you. So what? So using blockchain with IoT, it gives you this advantage that you can have secure data on a decentralized model, right? And as we were talking about the decentralized network, so another like a big usage of blockchain is in cryptocurrency. Like all of you must have heard about Bitcoin and cryptocurrencies. So what you can do is you can incentivize the users to use your network. So you can have certain rewards wherein if the user is using your network, you give them certain tokens and they can maybe use a token to buy anything. So the two problems that we were facing, the one with security and the one with cold start. So both of these problems can be solved using a blockchain. All right, moving on. So I spoke about blockchain, right? We'll be using blockchain with IoT. So what is blockchain, right? So one thing which I want to clear, like at the start, is that blockchain is not Bitcoin. Okay. So a lot of people have this idea that blockchain is Bitcoin. That it is not. Bitcoin is a cryptocurrency, and blockchain is the technology that made Bitcoin. Okay, that is uh, basically what was used to make Bitcoin. So there's a difference between blockchain and Bitcoins. So you can use blockchain to create cryptocurrency, but it has a lot of other uses. All right. So blockchain. So if you hear the word blockchain, you may think that it's so complex, but it is not. It is basically self-explanatory. You have this term block and chain, right? So what you have is basically a list of records. So records can be your data, it can be in cryptocurrency, it can be transactions and everything. So what happens is all of this data is gathered into what is called a block, and then all of these blocks are chained together. They're connected to each other using something called cryptography. All right. So if we come to it, if you want a technical, what do you call it, technical definition of blockchain. So blockchain is a decentralized ledger of all transaction on a peer-to-peer network. Okay, so you have to keep these terms in mind. It's a decentralized ledger. Ledger is basically a list of records of all the transactions, and it's a peer-to-peer network. Now, what are the key features which make blockchain so useful? So first of all, blockchain, the records are immutable. Okay, so the term immutable basically comes from mutation. Mutation means changes. So immutable is basically you cannot have any changes in the data. So once data has been put into blockchain, it will stay there as is. Second thing is it is secured. The other advantage is it is transparent because anyone can use this blockchain and see the data. So you can have different models. You can have public blockchains, you can have private blockchains. So depending on how who you want to share the data with, it can be done. So these are the things that blockchain has. Now, okay, so blockchain is okay. So the technologies that make blockchain are not really new. Okay, so it's basically old technologies which has been used in a new way. So some of the technologies that blockchain uses are cryptography. So cryptography deals with basically securing all of your data. So you can have different types of cryptography. You can have two-way, one-way. It's a lot of different things. Second is electronic wallet. So it's basically like a Paytm and everything. Third is distributed network. So distributed network is basically, as I told you, it's when all of your nodes, all of your computing devices are spread across a region, peer-to-peer, because two computers can talk to each other. So this is basically blockchain, right? So there are different types of cryptography that blockchain uses. There's systematic, asymmetric, symmetric, asymmetric, and hash function. You can go and read about it. I won't delve much deep into it right now. All right. So one thing that you should note is how do how does some data that you put into blockchain, how does it propagate to the network, right? So what happens is uh, all of your devices will be connected to a node on the network. So a node is basically a computing platform. So you can have a Raspberry Pi or like a PC or something. So all of these nodes are connected to different nodes which are near to each other. Okay, so one node can have like n number of peers. It can either be connected to one different node, it can be connected to 10 different nodes. It's basically all of them are connected to each other. Okay, so if you see in this picture, there's a node A, there's a node B, and there's a node C. Now, let's say, for example, this node is node F. So node F is not connected to node A directly, but through these intermediate connection, you can have a connection between node A and node F. All right. So what happens in this distributed network is once a data is sent to any node, it starts getting sent to its peers. So peers are the nodes which are connected directly to your node. Hi, so are we live? No, I mean, are we like on screen? Okay, all right. Okay, so I think, all right. So I think I left around this slide, right? Okay, so okay, so we were talking about cryptography. So there, okay, am I audible? Cool. So there are different types of cryptography which a blockchain uses. So you can have symmetric cryptography, asymmetric cryptography, and hash functions. So I won't go deep into this topic right now because we don't really have a lot of time. Okay, so one thing which I want to clear right now is how does the data which you sent into a blockchain network, how does it propagate, right? So you have, so what will happen is your device will be connected to one node, and now after the data is inserted into the blockchain, it will be propagated to all of the nodes. So what happens is all of these nodes, they connect to some node. So they can be connected to one or two or 100. It doesn't really matter. What matters is they should have some nodes. So if you see this node A, it is connected to node B and C. So node B and C are peers of node A. Okay, so what happens is when the data is sent to a node, it will send to its peers. And when the data reaches those nodes, they send to their own peers. And that is how data is propagated in a distributed network. So we talked about blockchain. So for this demo that we'll be doing in some time, so I'm using this network called Ethereum. So Ethereum is basically a public blockchain platform. So what it gives you is it gives you the ability to write smart contracts. Okay. So smart contracts are basically these pieces of code that you can embed into your blockchain. So if you want to process any data, if you want to write some functions that will happen when you send the data, all of those things can be done using smart contracts. So smart contracts are basically the code part of your blockchain. Okay. So that concludes the presentation. Now we'll move on to the demo. So I'll just, in brief, I'll tell you what the demo is about. So the demo is basically a small prototype which will demonstrate how can you make an IoT network use a blockchain for decentralization. So for this demo, what we wanted to do is we wanted to track your shipping containers. So most of the things that you ship, so if we're talking about industries or some global shipping, a lot of these things are done using your ships. Like right. So what happens is you take all of this all of this stuff that you want to ship to another place, and you put it inside a container. Now, what we wanted to do is track this container as it goes from one point to another, because it can go to some other port, and maybe the ship has docked in, say, port B, and then it will resume its travel to port C, and so on. So, what we did was we connected any IoT device, so say an Arduino board or a Node MCU. So all of those boards, they will send the data to a server, which will receive all this data over MQTT. Okay, so to explain about all the IoT part, I'd like to ask Robin to take it from here.
Okay, Jaraj, just a second. All right. So Jaraj gave a good overview of blockchain, I guess. So the purpose of this talk was mostly to let you guys know of the domain called blockchain and how relevant it is to IoT. So just a second. Now in this use case, we have the as he said, it's a basic asset tracking situation, right? So you have a container, you have its basic properties, and those can be transmitted by any IoT device. Now the IoT aspect of this is pretty simple. Most of the work has been done on the blockchain side of things, and basically all this is a MQTT to Ethereum bridge. So for those of you who have worked with IoT for at least a bit of time, you would know that MQTT is a very standard communication protocol. All even very well established companies like Samsung have their own iteration of MQTT. In fact, Samsung was one of the primary pioneers of MQTT. So it is a very industrial standard protocol that a lot of people use, at least with some customization. And the blockchain side of things involves Ethereum blockchain. So Jairaj has made a private implementation of Ethereum blockchain. And basically what we are doing is we are using an API called Web3 API. I think he has the slides for that. When we move on, we'll see the MQTT injection screen. So I think we can move on directly to the live demo, correct? So in this, just a second, I can't hear Jairaj without this. Okay.
Can you hear me?
Yeah.
Yep.
So the code that you see on screen are, I mean, it's not that complicated. The smart contract that you have written, that Jairaj has written, is not on screen right now. So the code is just basically taking data over MQTT and then publishing it into an Ethereum blockchain using REST. Now, what is the advantage of this? Almost all MQTT is a very low power thing. So anything of the scale of even a node MCU, or just pretty much about any microcontroller board that you have lying around is capable of sending data through MQTT. There have been even implementations of MQTT on top of LoRa networks that are very low power networks. So MQTT is a very widely used protocol, and what we have done is the project that we have done right now is for the benefit of demonstrating to you guys that blockchain has a very good use case in IoT, and we should consider adopting it. See, the first wave of Internet of Things was centralizing everything, right? And then blockchain is one technology that mostly arose out of that second decentralization wave. So now, as IoT is moving from cloud to edge, we still have such options such as blockchain to make sure that your data is immutable and stored in a very persistent manner. Now, how is this relevant? How is this decentralized? Now, basically, what we have running is we have an Ethereum blockchain network running on a Linode, a Linux instance on cloud. And also along with that, Jairaj has exposed the Web3 API endpoints. And what I've done is I've written a code to bridge MQTT to Web3. So basically, I can add blockchain records through any IoT device. And so that can be as simple as the controller of a smart shipping container. It can come alive. I mean, you can have an adjustable trigger. You can set it to wake at every 10 seconds, send the data. And so you have all the benefits of a low power IoT device, and yet all of the performance, or rather the security of a blockchain device. So if you want to usually whenever anyone says about Bitcoin or something, people think of like server rooms and server rooms worth of hardware for mining and stuff. So it's very powerful that something of such a small computing power can be used in such a very advanced application. So for this instance, it's just one. I think there are 3 nodes. There are 3 Ethereum nodes, Jairaj?
So there are 2 actual nodes and 1 boot node.
All right. So all this is deployed on the same server, I guess. Yeah. So and then the endpoint is also on a single server. But then in a real life, maybe a fleet management solution or something wherein you really need an immutable record, you can have it deployed across multiple networks. You can have as a ship is sailing from let's say West Africa to Fujairah or wherever, you can have ports nearby, you can have servers nearby that either make use of, if you really want to go off the grid and not use satellite communication, you can use ultra long communications. It can be even a network of ships. The possibilities are endless. Now, when it comes to a distributed model, the data is tamper proof. Like, even though, like, say Jairaj and I are sharing data on a blockchain network, Jairaj will have my data, but for the life of him, he won't be able to crack it. But then it has the advantage that should my data get lost, I can always get back from it. That is the advantage of blockchain. So now, enough of talk. I guess we can move on to the live demo.
Yeah. All right. So first of all, I'll start my blockchain network. So I have this thing called Putty. So what Putty does is basically you can create an SSH communication with a remote server. So I already have the remote server up. So I'll just connect to it and start.
Just a shout out. Let us know your questions in the comment section, and we'll be covering it in a Q&A at the end of this video. Okay, so please feel free to ask anything that you have.
So since I need, I think, around 3 of these, so I'll just duplicate it for now.
Maybe you can open a fourth one and run C matrix on that.
No, actually, I'll be using that for running the node.
Ah, okay. Can you press Control and zoom so that?
Yeah, sure.
Yeah.
Oh, wait. I think I entered the wrong password. Yeah, there it is. Is this visible?
Yeah, it's better.
Good. And I'll create a command prompt with which I'll run my Node app. All right. So I've created these scripts which start my blockchain server. So I won't write the whole code. I'll just run those scripts. All right. So this node is called a boot node. So what a boot node is basically it's a special type of a node, which okay. So a blockchain is a distributed network, right? So a distributed network needs to find the other nodes that are available, right? So if you remember this picture, yeah. So node A needs to connect with all different nodes, right? So it can connect to B and C. So how does it find what, like, where this node B is or where this node C is? So this boot node helps in that. So whenever a new node comes online, it connects to the boot node. It gets all the information of the different nodes that are connected to this boot node, and then it connects to them. So if you see, if I start my first node, all right. So if you see, when I started my first node, it started communicating with my boot node, and now they're connected. Now, when I start my second node, yeah. So when I start my second node, now this also starts communicating. Oh, wait.
Jaraj, if possible, can we maximize it a bit more? People
Okay.
are messaging me saying that they can't see.
Okay, wait. Can I zoom in?
Is Control and scroll wheel working?
No, I can't really zoom in anymore.
Okay. Okay, the important parts we'll bring to the maximum. We'll maximize during the important parts.
Yeah, I think I need to restart this Linode server. I
If you
already
want
had
to.
it running, and yeah.
Oh, all right.
So I'll just take like 2 minutes. That was reboot. Yeah, the thing is, I was already running the server, and then I kind of closed it. So
Oh,
the
you
node is,
spawned two instances parallel.
yeah. So basically, this node that I was trying to bring online, it was already running in the background, so I can't start it again. So I'll
Yeah,
just
got you.
reboot it and it should be.
Got you there. So Ethereum is usually known as a public blockchain, right? As
Yeah.
in it runs on public servers. But then here
Exactly.
you said that we've implemented it on a private server, on a
Private.
custom
Yeah.
Linode server. So
Yeah.
doesn't that contradict to what the popular notion of what Ethereum is?
Okay. No. So basically, what happens is all of these blockchain networks, they can be of different types. So you can have a public blockchain, like you have Bitcoin. So in a public blockchain, what happens is everyone is allowed to connect. So if you just like download a piece of software and you can connect to Bitcoin if you want to. Then you have these things called private blockchain. So in private blockchain, it is not okay. So no one whom you don't know can join. So basically, you can have authentication, or you can have uh, uh, you can have this way of only using your own devices. And there's another thing called a consortium blockchain. So in a consortium blockchain, it's basically meant for enterprise. So different companies can create their own blockchain service, which only that company or maybe a partner company can use. So there's different ways you can make your blockchain networks.
All right. So while you get that up, let's just answer some audience questions.
Yeah.
All right. An example scenario of blockchain in an ad hoc network.
All right. So an ad hoc network is basically a self-creating, self-healing network, right? So blockchain itself is an ad hoc network, basically. So if you see what I was doing here is basically I brought this node online and then I brought this node online. Now I didn't really have to go in and manually connect them, right? They found each other automatically and then they connected with each other. So you just create ad hoc networks inherently. You don't really need to program it for ad hoc networks.
All right, got you there. So it's a bit difficult to talk and manage the stream at the same time.
Yeah. All right, so I have the script.
Okay, the nodes are back up and running.
Yeah. All right. So now if you see, I've created my first node, I've created my second node, and then both of them are connected to this boot node. Now what you'll see in a few seconds, it will automatically start mining. Now I've programmed this so that it just keeps on mining. So I don't really have any issues with like transaction rates. In an actual implementation, what you'd probably want to do is when it gets a new transaction, only then it will start mining. So I didn't really do that right now, but yeah. So I'll now start the node app that we created. All right, so my node is running and all of these are running. So now let's see what we have done till now. So we have made a private Ethereum network on a remote server, which my computer is connecting to. And then we have a web server basically, which can connect to this blockchain, which will send data to this blockchain once it received the data on MQTT. All right. So now if you see, we have this. Okay. Now MQTT, Robin, would you want to tell about publish, subscribe?
All right. So the usual protocol that everyone is familiar with. Okay, I'm just covering basics of MQTT. I'm for the understanding of those who have not worked. So it's an IoET conference. Anyone with basic knowledge in Internet of Things would know the basics of MQTT. So just for the benefit of those who haven't heard of it before, I'm giving you an overview of what MQTT is. So if I were to explain MQTT in 2 minutes, I would say I would easily contrast it with what HTTP is. HTTP is what most people are familiar with because it's part of all of our URLs. So HTTP stands for Hypertext Transfer Protocol. So it's a client server system, and the primary disadvantage being that the client and the server have to be online at the very same time. So if A has to send a message to B, A will have to send it to a server. Server might record it in some backend, and the client B would have to again ping the server asking for some sort of access key to that data. So HTTP, like usually when our juniors approach us with IoT projects, it'll either be Blink, which we don't really consider, or it'll be the ESP web server example. So that's an example of HTTP. So MQTT runs on a publish subscribe model, as Jarad said. So it's in a very vague way, it would be a post office protocol kind of a thing, except you have several different topics. So you can any number of nodes can publish to any number of topics. So you can implement very high level organizational capabilities within MQTT. You can have an entire smart home architecture with maybe 12-13 bedrooms. You can have entire smart building architectures. Like when you do a system design, you can have topics, you can have subtopics, and only if all of those things match perfectly will the message be delivered. Also, if a client happens to go offline, here we don't use the term server, we use the term broker. The broker will ensure that the message is delivered to the client when it comes alive next. Now there are different modes of delivery depending on QoS 1, QoS 0, QoS 2, and so on. Let's not go into that much detail right now, but for the benefit of your understanding, usually a node MC would be sending this message, but instead to simulate a node MC or a microcontroller or whatever it is, it'll be sending the message. Instead of that, we have an MQTT simulator. So it'll just send MQTT packets to our server in the way that we define it. So I think Jaraj, you can continue.
So for this prototype, we are just manually sending these MQTT messages. But if we were to actually go into like proper implementation, this message would be sent automatically by a microcontroller board. So if you see, we are connecting to another remote instance. All right. So as Robin said, it's a publish subscribe model based on topics. Right. So I have created this topic called shipments. So now I can send different messages which will basically start different functions on my server. So if say I wanted to add some data, so add some data about a new shipping container. So what I'll do is, let me just check the function name. Yeah, add shipment. All right. So I'll type the function name. So say add shipment. And then I'll start giving in the parameters. So say it starts from Kolkata, or say it starts from Chennai. So India, Chennai. So this is my first parameter. So if you see in the code, you have to give these, what do you call it, 5 parameters, right? So you have to give it from where this shipment is going, where the shipment is going, what is the current location, or what was the last location, known location, what is the weight of the container, and a reference number. So let's say this was going to Australia. So Australia, say Sydney. And right now it's say in Hong Kong. So all right. So let's say the weight is 1000 kilos, and I'll give it a reference number of say 122333. Okay. So now if I publish this message, what you'll see is this Note app. Just a sec. All right, I think there's a connection issue. Just connect it again. Connection. All right. So let's publish it again.
Yeah, the screen's a bit blurred. Yeah, okay, all right.
Okay, alright. So, oh, all right. So if you see, this was triggered, and now this data has been added to my blockchain. So if you see here, this is the actual block, like the actual data which was stored in the blockchain. All right. So you can see a block hash. So a block hash is basically an identifier for a block. You can see the block number. You can see from where this data was sent and everything. All right, so this is basically the data has been added. Now, how do I see the data? So I have another function called, I think it was get shipment. So get shipments, and say I want to see the third entry, say. So if I do that, okay, all right. So if you see, we got this data. So right now what we did was India Chennai. So an ID is already like automatically given to the data that we send. And if you see, a timestamp is also attached. Now
Jairaj,
this
can you go a
looks
bit slow? There seems to be some
all right.
network traffic issue that's causing the screen to be blurred. Just a sec.
Okay, all right, all right.
Okay, go ahead.
Okay, right now it is visible.
Yeah.
Okay, so if you see, I sent a new message called get shipments. So when my web server receives this message called get shipments, it starts a function which connects to my blockchain and gets all the data for that shipment. So if you see, we receive this data for the thing that we did right now. So India, Chennai, Australia, Sydney, to Hong Kong. The weight is 1000. And we also have a timestamp. Now, this timestamp is not human readable exactly. It's based on Unix timestamp. So you have to convert it into like human readable code. That's not really a problem, but yeah. So basically, a timestamp is automatically added. Okay. So say this shipping container belongs to a person X. Now what you can do is you can give the person the reference number. Okay. So there's another function that I created. It's called getRef. So it basically tells you the last known location using the reference number that we gave. So the reference number, if you remember, it was 11222333. So now if I publish this message, what you will see is, just give it a little time. Ah, okay. Get ref message. Thank you. Okay. Oh, okay. I'll just publish it again. Yeah. So if you see, we tried to get another reference. I mean, another method which was called getRef. So when I sent my reference number 11222333, it sent me the last known location, which was Hong Kong. So this is a very basic implementation of an decentralized IoT network using blockchain. So you can do a lot more than this, but just to give you a brief idea, this is how it can be done.
Okay.
So I think
So
we
I
are done.
think for the sake of time, we better move to Q&A.
Yeah.
All right. So this was asked in the comment section. Okay, I'll read it out for you. You mentioned for P2P devices communication, they still use Wi-Fi 2. I'm assuming 2.4 gigahertz or Bluetooth for
Okay.
networking, but these technologies are not updated from decades. How to consider that in the security part? May I share my thoughts on this first?
Yeah.
Okay, so see, blockchain is a more, you can consider it as a more redundant database. So we are not focusing on the physical layer basically. So that is beyond the scope of what we can achieve through blockchain. And for that you might have to basically make a protocol stack from scratch of your own, custom design to what you have. I mean, Google's even working on Thread, and there are new protocols coming up that will better address those. But then that is the infrastructure. We are more on the application layer. So this question is basically it is definitely a valid question, but it is of a different scope. It is not related to what we are trying to achieve or the problem that we are trying to fix.
Yeah.
Jaraj, anything to add to that?
Okay, basically, okay, so you can have security even over Wi-Fi. So when we come to say transport layer, you can have something like TLS or something. So it's not that they are very unsecure. Okay, so you can add security onto it, but that's a different layer that we are talking about. So blockchain doesn't exactly deal with it, as Robin said.
Okay, I guess we'll take one more question.
Sure.
We are already way far due. All right. Apart from
Yeah.
any IoT implementations, can
Mhm.
blockchain be implemented in project management?
Project management. Yeah, obviously. So, okay. So blockchain is like blockchain can be implemented in a lot of scenarios. So as you mentioned, project management, right? So for project management, you can create this scenario where you have different managers, different project managers, and then you have some employees working under them, right? So maybe you want to track uh, who is working under which project manager or who is working on which part of a project. So all of this data can be secured on a blockchain. So wherever you have some kind of data which you want to secure, blockchain can easily be implemented in that. So I mean, if you look at some implementations, people are trying to add housing deals, medical data, so basically, there are a lot of implementations that you can do over blockchain. It is not really just for IoT or just for cryptocurrency. It's a very wide technology.
Yeah, the scope of blockchain is pretty wide actually. You can, I mean, there
Exactly.
have even been proposals to change property deeds to that, and there are certain governments who have
Exactly.
adopted that also. What we are showing is the scope of blockchain in IoT and how that would be a very suitable match. So I guess that I hope we have answered your question to your liking.
Do we
So
have
if
more questions?
I think we are about an hour and a half over time, so I think it's
Oh,
better we
okay.
wind up right now. All
Okay.
right, so Jaraj is the technical lead of the project team, and I'm the team lead. We work on several projects cross-domain, including IoT, blockchain, a few basic machine learning projects, web development, app development. So uh, it was a great opportunity to partner with Collabnix and Ajit sir especially, who gave us this opportunity. So I thank everyone on the behalf of the project team. And if you want to if you need any more details regarding whatever was conducted today, or if you are interested in collaborating with us or working on any projects in these domains, or if you want to get in touch with us, you can always reach us by our social media handles. We are always active on LinkedIn, Instagram, whatever that you prefer. Also head on over to ioetplanet.com, and we have a Slack channel. Do be part of the Slack channel. There are a lot of blog posts coming, and if you are an expert in any subject, you can even write your own blog post, and we'll happily turn your ideas into URL. All right, so with that, I guess we are signing off for today. Signing off from the IoET Conference 2020. I
All
thank
right.
all of you who have taken your time out of a Saturday to attend this. And
Thanks,
yeah,
everyone.
have a great day. And I think I'll cut to Shreyashri, who's the MC for the event. Okay,
All right.
bye,
Bye.
Jaraj.
Bye.
Thank you so much for such an incredible and inspiring talk. With this, we have come to an end to such a wonderful conference. I would like to thank each and every one of you, speakers, organizers, moderators, and of course the audience for spending your valuable time and energy on this platform and have such an stimulating and constructive experience of exchange of ideas. I especially thank all the active members and the speakers who were the key for this inspiration we are all taking back today with us. Thank you everyone for joining.